Hello.
Good evening.
Hi,
Yes.
good evening, sir.
Good evening,
I
sir.
believe everybody can hear me clearly.
Yes, loud and clear. To my side,
Please, okay, from your
my-
side, please,
from
every
my
other
own
person
side.
indicates then we are going to start with our introductions. After introduction, by then we'll have substantial number of the students in the ball, then we'll start proper. Please, okay, just hold on, I'm trying to share something. Okay, you can start introduction from your end, then I'll do my own introduction at the end. So
Good
please.
evening, sir.
Good evening.
I'm Bayode, Theophilus A. Bayode
Okay.
from Kaduna.
Wow. Inakwana.
Yeah.
Yeah, welcome on board. Yeah, fine. Fine. So what do you do?
I'm into construction building.
Okay, okay. Nice. Now you are welcome on board.
Thank you.
Yes. The next person, please.
Okay, good evening, sir. My name
Good
is Nduka
evening.
Alexis.
Alexis.
I'm joining this meeting from Port Harcourt.
Wow.
And, yes.
These are the wicked people of me.
You can say that.
Yes, sir. You're welcome on board.
The entertainer.
Yeah. So what do you do, sir?
Yeah, I've been to high voltage and lighting and earthing maintenance as an FM.
Okay.
Yes, sir.
Okay. You're welcome on board. So
thank you, sir.
Okay, next, please.
Good evening,
Hello.
sir.
Good evening.
Yes, good evening. My name is Raymond. I'm working. I'm joining from Lagos. I work as a facility personnel.
Okay. You are welcome on board, sir. We are both in Lagos.
Oh, thank you.
Okay. Next.
Good evening, sir.
Good evening.
My name is Kiri Olaye. I'm joining in from Abuja. I work with the Green Construction Nigeria Limited as the admin manager for the Expertus Farm.
Okay. You are welcome on board. How is Abuja? I hope Abuja is safe.
Yes, sir.
Yeah, okay. Welcome on board. Okay, next. Yes. The first lady in the house has spoken. So can we move to the next person?
Okay, good evening, sir.
Good evening.
My names are Shegun Akindele. I reside in Lagos. I work as a facility manager for Domino Group.
Okay. That's Lagos. You're welcome on board, sir. Next,
Thank
please
you,
make it snappy so that we can wrap up what
Good evening, sir.
Good evening.
My name is Uzoma. I am an architect in Enugu. Thank you.
Enugu, yes. You're welcome on board.
Thank you.
Good evening, sir. My
Good
name is
evening.
Adiola Anthony Obi. I'm an architect and I reside in Lagos.
In Lagos. Welcome, madam.
Thank you.
Okay, next. We have up to 20 students in the class, so let's make it snappy.
Good evening, sir.
Good evening, sir.
My name is Kingsley Anyang, electrical by profession. I stay in Lagos.
In Lagos. And your face look familiar, sir.
Master, please.
Yes. Okay. How is Rashid?
Rashid is good.
Okay. Okay. Next person, please.
Good evening, sir.
Good evening, sir.
I'm joining you from Imo State.
Okay. Okay. You're welcome on board, sir.
Thank you, sir.
I'm waiting, please. Okay, go to alternative gas. Do we have any other person on board? I believe everybody can see the screen.
Yes, sir.
So
Yes, sir.
if any other person is not speaking, probably you give me the permission to go ahead, please. We have close to 20. And those that are struggling with network, I would prefer you put off your videos so that I don't know if videos is allowed during the lectures. So if you are struggling with network, you can, okay, you will still need the videos on to see the lectures. Hello, Nduka has spoken, Shegun Ogun Toye. Then we have Abayomi Ade Lola has spoken, I guess. Then Adeola Antonio B. Then Samuel Ekemini Charles. Alice David. I hope we are all in the house. We are in the introduction section. Please, in 15, by 5:15, we are starting. Please do well to introduce yourself, what you do, then we can kickstart. Hello. Please, can I go ahead if nobody is speaking?
So I think you should go ahead, though.
Please go ahead, sir.
Okay.
Please go ahead, sir.
Okay.
All right.
So
Okay,
My name
go
is
ahead, please.
I'm hearing my name is.
my name is Ali Dauda Biodun. I'm an estate
Okay.
surveyor and valuer.
Okay. You're welcome on board.
Thank you.
Yes.
Good evening,
Okay.
sir.
Good evening.
My name is Eki Samuel Ekiminia. I am a mechanical engineer residing in Lagos.
In Lagos. I'm also a mechanical engineer, moved to facility management too. So welcome on board.
It is a pleasure, sir. Thank you.
Yes. One more person or two, then we go to the proper.
Good
Good evening.
evening, Mr. Engineer Facilitator. Shehu Ogunto is my name.
Okay. You are into what?
Are you hearing me? Yes, Shehu Ogunto is
Yes.
my name. I'm a mechanical engineer and I'm a facility manager. Thank you.
You don't balance the equation. Oh yeah, let's
I
move
don't
to the
balance
next
am.
person.
Mechanical engineering.
Okay. Okay now. Hello. Hello.
We can hear you,
Hello.
sir. Please go ahead.
We can hear you, sir.
Okay. Yes, I'm going ahead. Please, we'll save the introduction probably to a later time. So to save us time. Yes. Sorry. Yes, I am. My name is Engineer Ede Sirejurogene. I'm a mechanical engineer, certified mechanical engineer by NAC. I also did my master in facility management, University of Lagos. Then I also have a certified certificate on facility management through an American institute. Then I have 7 years experience. I'm trained as a HVAC engineer, both local and international. Graduate from Mambrusali University as a mechanical engineer, master degree in facility UNILAG, certified member of ProFM credentials, experience gained with Mandela's, Michael Hammond, MECON, Global PFI, then presently working with CBRA Accelerate. So please take note of all this brief introduction of students that have been done. Learners to consider their training areas, eliminate any possibility for interruption. So we are going to have this online training is going to be different from. I used to prefer interaction in class, but this will prefer us to just go ahead with the training. Then you save your question to a later time. I think we are going to have a break. Then maybe if Barakat is in the house, she can indicate when we are going to have break. Then we can have our question. Then we'll move to the next thing on the agenda. Then signify in interaction with the hand raising. There's a portion in your Zoom that indicates if you want to have if you want to ask a question. Then break times will be communicated by the facilitator during the training. Okay, facilitator. So that won't be a problem. So after completing this course, I expect you to be able to explain the various components of HVAC system. Different components of HVAC system consists of different components that comes together to form that unique equipment. So you need to have an understanding of what it is, have understanding of what HVAC maintenance is all about. Then understand various HVAC types. There are different kind of HVAC. You see window unit, split unit, chiller system, all kinds of system that you have. All of them work with the basic principle. Have knowledge of some basic problem of HVAC system. In your various site, there are problem particular to AC in your various site. So you will have an idea of what to do when the problem comes up. Then students are expected to know how to carry out audits and prepare a checklist. That's supposed to be a checklist. There's supposed to be a key there. Also show understanding of ventilation. Then often in most building and facility, what most of us fail to understand that ventilation is also a necessity in a building apart from air conditioning system. A building that is not well ventilated has direct impact on productivity. Then, first of all, we go straight to what the topic of the day is. So, it is HVAC maintenance. So, first of all, what is maintenance? Why do people maintain? So, maintenance in general can be defined as an effort taken. When I say effort, that has to do with you, your plan, individuals, your team, taking to keep the condition and performance of a machine. When I say machine, not just HVAC, it could be your generator, your lift, your building, whatever that is within your facility. Always like the condition and performance of the machine when it is still new. So what this is telling us that because you have a culture of maintenance, your equipment work every day as if you just bought the equipment. So that is the essence of maintenance. And if you look around Nigeria, you will discover that we lack the maintenance culture. You see people using vehicle, using equipment, using air conditioning system, using generator until they break down. They don't have that maintenance culture to ensure that that equipment walk through the lifespan it was designed for. So maintenance must be part of your culture. So if you are not taking care of your maintenance, at the end of this course, you will understand why you need to take care of your equipment. Then in the course of the maintenance, we discovered that there are different types of maintenance. We have reactive and unplanned type, which have corrective and emergencies. Then we have the proactive and the planned type, which has preventive, predictive, constant interval, age-based, imperfect, then reliability centered, then condition-based. Each of these maintenance actually can divide Nigerians into two by classifying this maintenance. There are more than 90 to 80% of Nigerians have the mindset of reactive maintenance. If the thing does not get bad, we will not fix it. That is reactive. If it does not get bad, we will not fix it. Your managers are having a board meeting. That is when your AC decided to pack up, and they all of them are well suited up for the meeting, only for you to see your boss blowing themselves with either paper or telling you to bring standing fan that they need, and you tell them what happened to the AC. Sir, the AC have not been serviced in a year. The AC have not been serviced in the last 6 months. That is a failure of a facility manager, a failure of the facility team on site. So most of us are designed to be reactive. So at the end of this course, you will know the importance of maintenance, why you need to move from reactive maintenance to proactive or planned type. Then under the planned type, you have what we call the preventive. When you say preventive, you already know what could go wrong in an equipment. So you make plans to get that equipment serviced. So a good example might be a monthly maintenance plan. It could be a quarterly maintenance plan. It could be whatever, or you look up your manuals. When you buy an equipment, there's always a manual. The manual give you the maintenance plan of each of the equipment. Most of us don't take time to go through it, but if you go through it, you see the maintenance plan in most of all those books, what you need to do when the equipment is running bad. Then for the predictive has a kind of graph. Those are used by big multinationals. They study the trends of the equipment. This involves a lot of data. You have to go to site every day, take record of what you have measured, then you put it in a data. So when you see that there's a deviation from the normal operation of that equipment, what happened? You begin to go ahead and maintain. Not that the equipment is bad, but because the line you are getting from your graph is moving away from the normal operating condition of the equipment, you carry out your maintenance almost immediately. Then under that preventive, you have what they call the constant interval, which you'll have your monthly. For your side, it could be every month that you are doing your maintenance. AC generally should be quarterly, but I will not tell you for your site to use quarterly. Your side, if you are in a very dusty environment, I would not expect you to do your AC maintenance quarterly. You can adopt a monthly maintenance. Please don't adopt a system that works in US, in Nigeria. Neither should you adopt what works in Abuja for Lagos. Look at what work within your location and find a way of ensuring that your equipment work optimally at all times. Then age-based, you look at the equipment is still working. You look at it, this thing is getting old. Okay, let me see what I can do. You service it based on that. That imperfect type is looking at irregular in time interval for the maintenance. You could just come, probably you are hearing some kind of sound, not that the equipment is not working, you will go ahead and you do your maintenance. Then on the predictive type, I've seen the reliability type where I said it had to do with the deviation from the normal graph of the equipment. Then the condition base are what you have carried out. You see that this data is showing some sign. If this sign is going this way from your data given to you by the manufacturer, you will see that this means that the bearing needs to be changed. Probably the sound level is going up. So because of the condition of the equipment, you carry out your servicing. The end point of your maintenance is that your equipment is working optimally. While you see some building have premium price, you see some building presently in Lagos, just within Lagos, because they are well maintained, there's a premium price on that property. Then if you go, there's no difference between my 12 markets and ShopRite. It is packaging. And when ShopRite came on board, they introduced air conditioning system and the rest. Before you know it, everybody wants to visit ShopRite. Even if you are not going for shopping, you are there to enjoy the cool and comfortable environment. You can't do that to go to our local market because there is not well taken care of. They are dirty. Well, this other one is huge. And what made us to work or use the ShopRite sell today is because the environment is well conditioned. And what does the work is air conditioning system. Then you also notice if you stay around VI, if you go to a place where businesses rely on AC for operation, the cost of their product or cost of their services are always higher than when you are not with air conditioning system. So you need to take consideration of your equipment in your building. If you must retain your customers, if you must retain your clients, you must take into consideration your air conditioning system maintenance. Just look at it. You visit an headquarter of a bank and well dressed, you only go to the place and you discover that the whole place is hot. You will not want to stay long in that kind of environment. You move out. So bank discovered that a comfortable environment also aid productivity, also increase their customers. So because your customer will tell, man, when you go to that place is cool and environment is very neat. So that increases their customers. So you can look at the deficiency within your own facility and find a way of bringing about improvements. Then for the reactive type, you already know it's corrective and emergencies. If the equipment does not get bad, we will not fix it. Just imagine a generator that been giving a loud sound, AC that been giving a very terrible sound. Oh, tomorrow I will fix it. You keep postponing, you keep postponing. The result of your postponement will always lead to what they call an emergency. An emergency is not good for a facility. An emergency is not good for facility management because this affects your performance in a year. For most of us that have KPIs with our clients, if you have series of emergency within your building, you will lose your job. For those that are on KPIs, please, I tell you to move away from this reactive to preventive. Then our focus will be plan preventive maintenance, which is the maintenance that people have practiced and they've seen to be very okay. So preventive maintenance is the regular and routine. Please take note of that word, regular and routine maintenance of equipment. You know, sometimes your technician will come to you, Oga, time don't reach for us to maintain. You say, Oga, but the unit see the work now. Why you want change? Why you want to maintain? I bet leave and make with it. You don't do that. Please, at the beginning of the year, you are supposed to make your budget for maintenance. You should know how much you charge for your maintenance. Those of us that are facility managers, those of us that are collecting rents, that are collecting a bill from customers, you need to have a maintenance plan at the beginning of the year. Based on your maintenance plan, you can raise your budget. If your AC has to be maintained monthly, you are going to do maybe your split units is about maybe 3,000, 5,000 per AC for maintenance in a month. You just multiply by the number of AC you have. You understand? Then after you've done that, if you have about 10 within your site, so you multiply 5,000 by the 10 AC, that is 50,000. Then you multiply by the whole year, 50,000 times 12. That is 50,000 times 10, that is 600,000. You put that on your budget for the year. So if the price varies from different companies to the other, if your major maintenance plan is just for filters, washing of your outdoor unit and the rest, your price could be far lower than that. Then if your maintenance is going to go with repairs, please, I will advise you to be careful with repair. When you are doing your maintenance, separate your maintenance from repair. They are two different things. If you go and cost for maintenance and repair and you put a budget down, because if and your power within your facility are not good, you might finish your budget in 3 months into the year. Because if your compressor keep getting bad, you need to fix it because you have signed with your client that you are going to be doing maintenance and repairs. Repairs, sometimes if you have estimates of how, for those that have experience, that these are things that can go bad in a year within my facility. Okay, let me budget about 2 million, 5 million to cover for the repairs. But you could also do it based on requests. So anytime if a unit goes bad, you let your client decide, because cost also varies. You also consider Nigerian situation. Nigeria market is based on dollar rates. So if you do your budget when the dollar rate is at 500, don't expect to buy the same equipment when the dollar rate is at 700, which is around that figure now. So it will have direct impact on your maintenance. So the advice I will give to you, you can leave it based on request. When you discover a compressor is bad, then let the client call you, do your quotation, send it to the client. Then based on that, you pay for it as it is now. Then your guys knows what to do to get it fixed. So don't forget, preventive maintenance is regular and a routine maintenance of equipment and assets in order to keep them running and prevent any costly or planned downtime from unexpected equipment failure or breakdown. I believe we understand that clearly. So please take note of regular. It has to be regular. Routine maintenance of equipment and asset. Asset could be anything within your facility. It could be your AC, it could be your generator, you name it, whatever you have. In order to keep them running, that means the thing must constantly be running and prevent any costly unplanned downtime. Costly downtime could affect, if you are in a building where ACs are in a server room, and your maintenance are not being done regularly, your server room could decide to break down on a Friday and people want to go to bank to withdraw. I notice sometimes when you go to withdraw during the weekends, you can't get your money out. Sometimes the server work to the extent that they get so hot. If the AC are not cooling your server down, they will begin to shut down. And if they shut down, all your clients try to either get something to do online or your server, it could be MTN. NTN, they have base station at different locations. If there are no ACs in their base station, people cannot make call. So the life of some company depend on air conditioning system. Be it an electrical company, you say refinery, they don't need air conditioning system. They need air conditioning system. When you are extracting different components from crude oil, you know, when you extract crude oil from the ground, you have this black solid thing that look like pap. So you pass them through the fractionating column at different temperature. Kerosene will move out, diesel will move out, petrol will move out, bitumen will move out, benzene will move out, methane and all that chemicals will move out. At a particular temperature, they will go out. What ensures that this temperature are met are air conditioning system. Then you have a gas station too. You need air conditioning system to control the control room for the gas station for supply. Because when electrical, you know the law of physics for those of us that are engineers, each time you do work, energy is generated. If you bear rubbing your hands together, energy is generated. And those energy generated, because you are in an enclosed environment, the heat will begin to accumulate and the temperature begin to rise. So the only component that can bring this temperature down is your air conditioning system. So in order to ensure that air conditioning is working optimally, you must ensure your maintenance plan is in good and not faulty. So, sorry for this. I think I have to drag this thing to go down, 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 down. A successful maintenance strategy require planning, then scheduling maintenance. So you might say, how do now that I've listened to this lecture, how do I carry out my maintenance plan? First of all, get your manual. If your site is very clean, then your air conditioning system could be maintained quarterly. Quarterly means every 3 months. Just divide the 12 months by 4. You are going to get 3 months. So if your first maintenance is in January, you know that after 3 months you have your next maintenance. Then you can raise up a schedule either through your calendar. Those of us that knows how to use calendar on the, I think Google too have calendar. They have your team also have calendar. They could send reminder to you. You can program it in a way as if you're having a meeting. Then put all your plans for your maintenance of your asset within. So once it's time, it sends you an alert. You understand? For the time you will need the maintenance done. So this allows the equipment to be in good condition at all time before problem or breakdown begin to come into it. I think I have to move this thing to the side. It's really disturbing. Okay, it's better this way. Then please note, the frequency of air conditioning maintenance depends on the quality of its environment. When you are talking of air conditioning system, there are two things you need to take consideration of: the indoor air quality, then the outdoor air quality. The indoor air quality, that is the indoor unit suck air from its environment. When you are there, the split unit has two portions. Underneath, you see a particular a plastic material made to blow air out. Then on top of it, there's a return. So there is a circle, there is a movement requires for cooling. If you have so much dusty environment, it is required that a filter must be installed on the return line. So when filters are installed, it enables the cleaning of that environment and allow clean air to come out from the cool portion of it. Then outdoor air quality, when you install your AC, the outdoor unit, the ones that are installed outdoor, if the environment is dusty, there's bound to be problem with your system. And if care is not taken, air conditioning system could actually fail. And if your equipment is not well protected, or it doesn't have a safety device to protect any power surge, your compressor is the one that suffer the most from any outbreak of air quality within that environment. Then for clean environment, for a clean environment, please take note. Those that stay in environment that is very clean, not dusty, a half-year biannual preventive maintenance plan is required if it is a very clean environment. For moderate environment, not too dirty but still clean, a quarterly preventive maintenance is required. But for polluted environment, a monthly preventive maintenance is required. But for extremely polluted outdoor environment, a fortnight, that is happening or produce every 2 weeks. What I'm trying to say there are some environment that are so dusty. Anytime you see vehicle move, dust rise up in the air. The AC actually suck this air to cool the compressor. As it's sucking it, we have dusted around each of the outdoor units. Care must be taken for you to know what work for your environment. And based on which of these choice, you can now raise your budget. Please take note of how to raise budget for AC. If you have, like now, if you are having a chiller system, a chiller, cost of maintaining a chiller is actually different from maintaining a split unit, actually different from a standing unit, those type we have in banks. So you could work out the formula that works for you, have an agreement with your client, then you begin to implement. The major focus of facility management system, when you are talking about AC maintenance, your focus is the people, your focus is process, and your focus is the place. Why do we say people? You need people to increase productivity. Why do we cool an environment? You want the people to work optimally. You don't want your staff working, your visitor coming to your building, your customer, even your staff, your AVAS team, your facility team. You understand? Once they come into the building, they're always feeling hot. And if you feel hot, what happens? You sweat. And before the day runs out, you see that you start having some offensive odors and the rest. But AC, try to keep those in check. Ensure that the environment is within a comfortable temperature. Then the process, it could be activities carried out within an organization with the aim of fulfilling their business objective. What activities do you carry out? A shopping mall is a business. What do they do there? They do a lot of buying and selling, people coming in and going out. Then when you talk about a church or a mosque, it's a place of worship. People go there and come out. Then when you talk about different kind of churches, Sele and the rest, you see some church, they dance a lot. So the kind of AC you put in all those places are far different from a place where you design for a library. So the process, what they do also determine the kind of maintenance plan you are going to have. Then place, location also matter. When we are doing introduction, I heard some people saying they are in Abuja, they are in Enugu, they are in Lagos, and the rest. If you ask which state is the dirtiest of all states? You hear people shouting Lagos, Lagos is dirty. You understand? But if you go to, I don't know how clean Abuja is, but I know Enugu should be clean because they have a lot of forests or bushes around them. Those trees and plants enable dirt to be removed from the atmosphere. So environment that does not have too much trees and the rest has a lot of their implication on the environment. You'll see Lagos. Lagos is beautiful, but we don't have a lot of people planting trees around everywhere. That's why you have the rate of high people coughing and the rest. A lot of pollution from cars, pollution from the environment, pollution from industries, pollution from bad road, and a whole lot of them. You understand? So all those locations to have their effect on your decision when it comes to maintenance. Then why do we need to maintain our HVAC system? Why? What is our aim? To create comfort, a comfortable environment for our staff. Improve indoor air quality. You know, I told you the indoor unit have filter. Your central system through the air handling unit, all of them has filter. The essence of the filter is to remove dirt coming into the environment. I know most of us must have heard what they call SBS, sick building syndrome. There are some building you will go to, you will sneeze as you are going out. There are some building you will go to, you will feel sick entering the building because the environment is so soft that the air is filled with microorganisms. So taking those things in actually have that effect on your lungs. Some have affect your chest. So clean environment is good for your staff and also good and also improve your reputation as a company. Then it saves money because when you do your maintenance periodically, you will not meet Kasali or meet a maker that will tell you, Oga, this thing I'm going to charge. Normally the price should be maybe 1,000, 2,000 for the particular thing. Then the guy is telling your guy, since it's emergency, you are paying me 10,000 naira. And your clients keep calling you, say, oh boy, what is happening to I can't stay in the building. If you don't fix this thing, I'm not going to pay the rent. You understand? So it will increase. Emergency always increase cost. And most of us know when you want to take a passport that you take 2-3 days, you pay less. But if you want emergency, the price is always higher. So take note of all those things. Then to reduce total breakdown, you don't want your equipment broken down, most especially if your equipment is the type that was brought in from the US, brought in from the European country or any other country. Nothing is produced in Nigeria. So if it breaks down, how do you replace it? Prolong the system lifespan. The equipment, because you are maintaining them, you see that their lifespan expand. They might tell you the regular year for an AC to work in a building might be 10 years, might be 15 years. Because of your regular maintenance, some equipment can actually last up to 15 to 20 years because of your culture of maintenance. Then reduces noise. Some equipment that are not periodically maintained, you see them making noise. Some equipment, because the place you are supposed to put grease, they are not wear grease, you start perceiving noise, the bearings start having fault, and if bearings start having fault, any moving component within those machine begins to break down. Those that are engineers in the house also understand. Even those of us that are not engineers, you know, when you start hearing noise from your car engine, what happened? It can knock, it can break down. You understand? So to keep the humidity and the temperature within regulated amount, you ask your question, what does humidity get to do with your environment? Humidity have a lot to do. Then I will break it down. Humidity is talking about the amount of water in air. And if you don't understand it, I will explain by 2 scenarios. Presently now, you see that the weather is very cold. Any clothes you wash presently, if you dry, because there's no sun, it takes a longer time for it to get dry, because presently there are a lot of water in air. If you have an equipment to measure your outdoor air, you see that the water quantity within Lagos is between 80 to 95. Too much water in air. And this thing also affects some of our building. You see them, the blocks will start peeling up because the walls are absorbing too much water. You understand? So as it's peeling off, it releases cement, block, dust into the air that you can easily take in and make you start coughing. Then you talk about temperature. Temperature too matters a lot. Every average human temperature is 36 degrees. Anytime you go to the hospital to maybe to check yourself up, to see whether you are okay, once they put the thermometer between your armpits, you will measure 36. It could be 36.7, 36.8, but the required temperature, if it goes beyond, there's something wrong with that person. And if it goes below, there's still something wrong with that person. So you need to go for maybe treatment or something. So the regulated temperature to keep our body normal is between 22 then 25. So if the temperature is between 22 25, meaning the temperature as is cool is extracting heat from our body. Then another thing you need to consider to improve efficiency of our electrical system. Some of our electrical system are need AC to work efficiently, like the server room I've mentioned, like the power stations that have big equipment installed within their facility. You need AC to keep them running. Why MTN was able to have their base station a ducted environment around is because they made enough provision for air conditioning system for their control system. Then to keep our data center running, that also matters when you talk of bank, you talk of control room and the rest. So it keeps that environment clean. Then to increase productivity. The essence of company or you establishing a company is to at least increase your productivity of your staff that are working with you. Any productivity that is not increased means you are going to run at a loss during those periods. Productivity have direct impact on your profit. If your staff are comfortable, they will work optimally. So your AC needs to be maintained at regular interval. Then the topic of the day, What is HVAC? You ask yourself, oh, HVAC, I've been hearing HVAC. What does E indicate? HVAC, the H there stand for heating. Believe we can, I hope everybody can hear me. Hello?
Yes, we can hear
Yes,
you.
yes, yes, we
Okay,
can hear.
okay. I need
We
to
can
hear
hear you,
this.
sir. Yes, we
Okay.
can hear you.
Then the HVAC, the H within that word start for heating. Then the V is for ventilation. Then we have air conditioning system. What most of this topic we deal with is air conditioning system and ventilation. Then heating might be needed in some environment, not all the environment. There are some equipment that are called heat pump. They have the capacity to cool and at the same time heat. Nigeria is located around the equator. Because we are located around the equator, the temperature within Nigeria is very high. That's why you see that Nigeria, but we don't have what they call winter. Those areas that are far away from the equator, when I mean the equator, at the center of the earth, is very, very hot. We have partly Sahara Desert at the northern part of Nigeria. Why Lagos seems to be cooler is because we are closer to the Atlantic Ocean. So once the sun hits the water, the pressure from water and the rest brings cool air to our environment. That's why we perceive cooling. Then any environment that has a lot of trees and have a lot of gardens around them environment, those environments seems to be very cool and very okay. So eating might not necessarily be what we would talk about, but it's something that is opposite of the air condition we talk about. Then ventilation also needed. When you talk about extracting smell, odor from your facility, you talk about ventilation. Then if you don't have money to afford air conditioning system, ventilation could also be a means of cooling yourself or cooling your facility. Then, which is used to maintain or control an environment within a building of the occupant or for the process being conducted. To maintain the environment, the HVAC system controls some factors. Your HVAC, that is your air conditioning system, your ventilation or whatever, they control the temperature. Once the temperature within the place is about 28 or 30, once you put on your AC, definitely the temperature will drop. And if the temperature does not drop, your AC is having fun. Humidity, it will also control the amount of water content in air. The standard recommended for basic equipment is plus or minus 50. When I say plus or minus 50, is between 45 and 55. It could go it could go to about 30 or about 60, but it should not go lower. If you go to the northern part of Nigeria, one of our brother mentioned Kaduna, Meduguri, the humidity around that place is very low. When you measure there, because of the heat, the water content in air is low. You can measure up to 10 or 20 around that particular place. You understand? The air distribution, by virtue of movements, your AC blows in cold air and take in hot air. By that movement, it controls the movement of air. Then you talk of air quality. The filter within your AC actually remove the dust within your environment. Clean. When you are doing your maintenance, it's one of those things you must bring out, your filter. Clean it, ensure it's dry, then you install it back. The air velocity also matters. When you are in an office that is very wild, if the air velocity is not good enough, it will not get to the end of your room. If you are installing, if you see most of the tent we're having around this day before the COVID, we saw the people going to build tents for occasion, wedding, to bring people in before the COVID. But what they've been able to do is to use air conditioning system control that environment. Then they consider the air velocity, because the air velocity actually determine the throw of your AC. If your AC is not well designed, you'll be surprised that people about 1 to 2 meters from your air condition are the one feeling the cooling. Then people beyond 2 meters away from your AC will be feeling hot, because your air velocity cannot take the air up to that point. Then noise level also too matters. There are some ACs that actually have this butterfly fan. When I say butterfly fan, you see some bird or butterfly, when they fly, you don't perceive or hear any noise, but here they move. So there are some fans that actually been created to reduce noise level within a facility. Then what are the basic components of air conditioning system? Basic component of air conditioning system. You ask yourself, I say AC, 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 what are the things that make it up? Yeah, what makes them up are your compressor. And your compressor look like human heart. Exactly like human heart. Something is popping blood out, something is taking something in. Your vein and your artery. The same way your AC also work. Your compressor is the key component in air conditioning system. After that, you get to your condenser coil. I will show you better in the next page. Okay, let me use this diagram. This is your compressor. I have to be moving this. Okay. This is your compressor. So there are some gas they call refrigerant. The work of the gas is to cool. They discovered that we have fluids. Among the fluids, we have normal air, then you have water and the rest. But water actually cannot be compressed. But some gas can be compressed. Then over time, we have evolved from moving from toxic refrigerant to more environmentally friendly refrigerant. We used to use ammonia. Ammonia is still being used in refrigeration system. Please take note of that. So they discover some refrigerant actually have cooling effect, which are cooling effects is the same thing as a refrigerating effect. So when the compressor, you put your power on, you connect it to electricity, what happens? The compressor, it takes the time to work because there's some oil that is within your compressor. That oil sometimes will turn to solid. You know, when you leave palm oil within the kitchen, what happens to it? It forms solid until you put it on fire. So those, when you put it on, the essence of that power on is to melt those oil within your compressor. So when those oils are being melted, the gas will now move through those oil and go straight, as you are seeing it now, straight to your condenser. Your condenser is made up of aluminum fin and copper. Aluminum fin and copper are very good heat exchanger. For those of us that are engineers, you know metal is a good conductor of heat. When you put metal on top of your stove, like those of us that cook in the kitchen, our madam, when you put pot on fire, you see some of the handles are made with plastic and the rest. But for this particular design, they intentionally use aluminum fin and copper. So the essence of the copper, it allowed the refrigerant to flow within it. Then on the surface of the copper, they have some aluminum fin. The essence of the aluminum fin is to create equal distribution of heat that is coming from the environment. So as you on that, the compressed gas here, I think I have to pull up the whiteboard. Okay. This is so right. Can I write something? Okay, please, I need to draw some things for you to have an understanding of what I'm saying. Presently, this man, you have to move a little bit up. Presently, when these guys move, there are three basic things we consider in engineering. Also, your facility, we have what they call pressure, we have volume, then we have temperature. So for this training, we are going to be talking more of pressure and temperature. So when you compress, sorry, this might take some time. When you put your power on and you compress the refrigerant gas within this place, what happens? The temperature increases, it goes up, and the pressure also goes up. Please take note of this effect. Based on this understanding, you will now know what to maintain. When there's a fault, you can troubleshoot. So when you compress, the pressure actually goes up, the temperature actually goes up. So that temperature going up is what is indicated in those red lines. And you see the direction of the arrow. And as it goes up, the same pressure and temperature is still active within the gas. So when it goes to the outdoor unit, the essence of the outdoor unit is that it ejects heat. It sends heat out. So because the refrigerant is hot and is moving with high pressure, it goes into your condenser. Your condenser now ejects those heat out. It ejects the heat out. So as the heat is going out, some of your staff on site, what do? They will go and dry their wet clothes. They dry their wet clothes, their wet canvas, or they just stay beside it to keep themselves warm. But it is not advisable to totally block the heat being ejected out. If you do that, the heat will begin to accumulate within this, and they can have direct impact on your compressor. So I will give an example. Okay, I can give an example now. There was a facility I went to do more like an inspection. They discovered that their AC, their central system keeps shutting down. Why was it shutting down? They undersized the HVAC system, and the generator size they bought was actually low, was actually smaller to the load there. So when can they increase? There's a lot of customer coming in to buy. Each time customer come in, they say, man, this place is getting hot. Because of that complaint, they begin to lose their customer. So they called us in. So when we inspected, we discovered that the outdoor unit was actually installed in front of a generator. And the generator, because it is running 24/7, it is overheating. So they opened the door. So most of the heat from the generator was actually going towards the AC. So once the AC gets the heat up to a particular level, and because the compressor have a protective device, the AC shut down. And because the AC shut down, the heat within the environment, the space where they are doing their business, the heat begins to go up, and customer begins to complain. So the solution is for them to relocate that outdoor unit away from that place and install in a well-ventilated environment. So that could be the solution. So the next part is that the pressure here, because the gas is in the condenser, the pressure is still high. Because the heat has been ejected, the temperature has dropped at this point where you have the condenser. Then at the point of the expansion valve, the work of the expansion valve is to reduce the pressure. So at this point, the pressure is still high and the temperature has dropped by virtue of eject of heat from the condenser. So at this point, the work of that expansion valve is to reduce the pressure. Because it has reduced the pressure will drop here. The temperature too has dropped. By the virtue of these two components having their characters drop, the refrigerating effect, the cooling effect that we are looking for has been achieved. Then it goes straight into the evaporator. The evaporator is actually in your indoor unit. You see that it is marked with blue, meaning it is cool. So what happens here is that in a space, the hot air is sucked at the top of your AC, while the cool air goes out under your AC in this faction. So this one keeps supplying cool air, while the hot air, you ask, where is the hot air coming from? From your body. Human beings' temperature is high. Your TV, your system, your electrical equipment that send heat into the environment. So those ones are sent up through this point into the evaporator. So once it enters into the evaporator, it cools it, then it sends it out. Don't forget, they have a fan that control all these things. There's a fan that control the movement of the air. As the fan rotates, air is moved throughout the equipment and sent out. There's also a fan within this place. So the basic components I've just mentioned now are compressor, which we've talked about. We talk about condenser. We talk about expansion valve. Then we talk about evaporator. You can call them the 2Cs and the 2E. So those are the basic components of air conditioning system. Every other component you see are just adding to the efficiency of the air conditioning system. Can I go further, please?
Yes, yes, you can.
Yes,
sir.
I think I have to start. The work to erase now is a big one. Okay, I'll have to rush and start cleaning. I think they've improved this. That's good. That's good. So it will not disturb the next slide. Okay. So other components include evaporator fan. Like I said, in the evaporator, to push the air, sucking of the hot air and pushing out of the cold air, you need an evaporator fan, and it comes in different form. They are mainly in circular form. Then when you go to bigger unit, like your air handling unit, you see what they call a centrifugal fan, or some are installed as their fan, depending on the force that they need to push out air. If it is a ceiling type, they use high static pressure fan to push out the air. Condenser, you need your compressor cooled. So in order to cool your compressor, you must leave enough space at the back of the AC and a maximum of 1 meter space in front. So as it's ejecting the heat out, cold air from the environment is coming into the unit and cooling the compressor itself. That's why it is painted black. Black body attract a lot of heat, so you also eject a lot of heat. So by that, your compressor is cool. You have electrical cables. These are essential components in AC. You can't put all those components together without a cable. Your indoor unit have to be connected to your outdoor unit. So when you power on, your outdoor unit, your indoor unit will come on. Then we have dryers in bigger equipment. The essence of dryer is to remove water moist that must have gotten into your unit, because if water gets into your unit, it will aid corrosion. So in order for it not to corrode, there are some chemicals that actually absorb water. So a dryer, you see them inside the dryer. A side glass also in a bigger unit. The essence of side glass is for you to see the movement of the refrigerant and know whether it is wet or dry. There are indicators like yellow, blue, red, or white on top of it, telling you it is okay or not okay. Then temperature sensor in front of your indoor unit, there's a sensor installed inside. If that sensor, when during installation or during maintenance, if that sensor is not installed back, your remote control will not work efficiently. When you control your AC with your remote control, you're actually telling the sensor to sense the cool air within the AC and regulate it to this temperature. So your remote control actually work with the expansion valve. It tells the expansion valve how it needs to open or how it needs to close. So those temperature sensors are very important. Like your doctor in the hospital, before they can tell you are not too fine, they measure your temperature. And based on that temperature measurement, they will tell you are not fine. You are having fever, you're having malaria, you're having typhoid, and the rest. Thermostat also give you an indication of the temperature of the AC that you are receiving. There are some units that have like a thermostat on them. There are some that you have to keep somewhere to measure. Then we have capacitor. Capacitor aid the working of your compressor. Compressor have high starting current. So in order for them to work smoothly, they install a capacitor. Once it pick up from your power, the capacitor actually add to the amperage that your compressor is receiving and boost it up to work. Then your compressor can have a value of maybe 30 amps, for example, not to be specific, for example, 30 amps. So as it's drawing 30 amps from your power, the actual starting current of that compressor could actually be 40 or 50. So your capacitor aid that compressor to attain to that 50. Then once it has attained it has finished compressing your refrigerant gas, then the amperage will now begin to drop to the normal one, which is 30. So for those of us that are engineers in the house, please be careful when you are doing your load selection for your generator. There was a friend that made a mistake by selecting the actual running current of the ACs to select their generator. So when they were commissioning, they have close about 50 ACs that they put on the generator they bought. So when they were commissioning, the ACs were on at the same time. So because of the high starting current, each time the ACs want to pick up, the generator will go off because the generator cannot sustain the power. So what I'm saying in actual fact, if you want to select your generator, please use the starting current, not the running current. Then type of air conditioning system. In a building, you have different kind of AC. If I begin to ask us individually, you see that different ACs installed in our building. So you could have a ducted unit, you could have what they call non-ducted units. So non-ducted units are your split units, the one you have the outdoor outside, then your indoor in. Then we have the window units. You don't need any component to convey the cool air to the location. So your window unit also fall within the non-ductable units. So you don't need anything to convey the cool air. As you generate the cool air, is pumped into the space directly. It could be a ceiling concealed unit, it could be a cassette unit, it could be anything. So long there's no connection of duct, it is called a non-ducted unit. Then what fall under that group are your split units, your window unit, floor mounted unit, wall mounted unit, your ceiling mounted, your exposed type. There are some units that are exposed. They hang halfway. You can hang them halfway your wall. But most of those units are old-fashioned. They are no longer producing them. But if you go to some old building, you see one or two of those units. Then you have the hidden away type. There are some units that are hidden. They hide them, but it's also cool. They are old type. Then you have the cassette unit. Cassette unit seems to be very sweet in design because you don't actually have it to be mounted on your wall. It is mounted on your ceiling, and care must be taken that you must ensure your drainage system is well designed. Because if your drainage system is not well designed, you have rain, you create artificial rain inside your facility. Then you go to the ductable unit. Why do we say ductable unit? The ductable unit means the cooling system is generated somewhere, but is needed elsewhere. In order for you to transfer that cool air generated to the place needed, you now need what they call a duct. Ducts are galvanized sheet of metal formed into shape, conveying cool air into different points from different outlets. And you always have what they call a diffuser attached to their different points. So I will show you example as we go below. Then we have what they call package condition. They are also working with this. So long there's a connection of duct, then they fall under this group. They also have central system. Your chiller system only cools, then send the cold water into your air handling unit. The air handling units connected to your duct actually convey the cooling required to different places. Then you have floor mounted, you have the air cooled ductable unit, you have the air cool type water cool, we have your DS system, we have your chiller water system, vapor compression unit, vapor, and the rest and the rest. You can read all those ones. So let me not make it look too complex. So as you are going down, the sizes and the capacity of those things keep increasing. You understand what I mean? So your reciprocating units, this one might be needed in industries. They are very big and capital intensive. We have centrifugal unit type. They are specific. There are some temperature that needs to be achieved. A particular temperature needs to be achieved. A particular equipment designed to take care of that. Then I give an example where I once went to a newspaper, a company. They called us for an inspection. We go to the newspaper company. The problem they were having is that their product, their paper, was actually absorbing water. They were producing the newspaper with an environment having close about 80-90% of water. So what happened? You know, when you keep something dry somewhere, what happened? It draws water. All of us eat granite here. If you have granite in the house, just do a simple experiment. Expose it for about 1 hour. Then go back, pick that granite and eat it. What happened? Water, the dry granite absorb water. Your biscuit, your digestive that you eat, they are produced in an environment that is dry. So they use the humidifier through some air conditioning system to control the atmosphere to achieve that dryness for producing those biscuits. If those things are not done, you discover that your digestive, when you are eating it, they are soft. So it reduces sales. So you understand? So there are some particular AC designed to do some other thing. AC is not just created to cool human being. They're also created to cool equipment and to carry out some function. Please take note of that too. Then different type of air conditioning system. Uh, sorry. It's different type of air conditioning system. You have the window units. This one is very common some years ago, still common today, but it is not good for a luxurious facility. You have a facility like a shopping mall. They now said, please, I don't have money to buy chiller system. Please put window unit in all the office. You are going to create robbery, because when you are going to install this, you are going to open the wall. And in opening the wall, some people that are smart enough, they will cut a burglary, drop your AC, and come through your building through that means. Then it also defaces the building. When you talk, we have an architect in the house. When you want to build a high-rise building, maybe 20-story building, you want to recommend them to be using split unit in this modern generation. Split unit are used by window units are used by those that can afford it, and most of them are built based on R22. So R22 is not good for the environment. So that is it. But they cool very well. If you go to Bishop House in CMS, when you look at the building, you will shed tears, because the kind of, you see different kind of AC pump shooting out from different locations. It defaces the building itself. So if you want to increase the value of your property, I will beg you to ensure that you use AC that go in commensuration with the aesthetics of your building, because it increases the value of your property. So where can we use this? You use this in school, higher institutions. Students will love this kind because they are cheap. Hotels, some hotels low, maybe 1-star, 2-star hotel, and the rest. Then residential apartments, some people prefer the split unit. Then some offices too also prefer it. It's not a crime. If you can afford it, then you go ahead. Then we have another type of AC, which is very common, the split unit type. This one I use in various homes. I believe some of us have this at home or have it in our offices. They actually remove the disadvantages of the other ones I just showed you. You see the installation here. This is the outdoor unit. This one is actually installed outdoor, while this is installed indoor. So there's a connection of your copper, the suction line, liquid line that will be connected to your outdoor units. So those are the things that must be solved. So you see the small diagram I placed here. So you just open a small wall, you do your connection to your outdoor units. So as you put your outdoor unit, you see behind it, you see that you have some space behind it. Most AC in a building, they are installed too close to the wall, and some even closer to the wall. There's no space in between. The back of the AC has some copper pipes, an aluminum fin with some mesh to prevent maybe dirt, rodent, and the rest. The essence of this space is for the unit to be effectively cooled down by the environment. If you stamp it close to the wall, you give a problem. I give an example. I also went along Body Lawn in Ikoyi to do an inspection in a building. The people are complaining that the AC within their room keep getting hot. When it is rainy season, the ACs are working well. When it is dry season, the temperature is very high. So at a particular point during the dry season, the temperature within the indoor is going high, because they will discover that the AC will shut down. What is causing the AC? In front of the AC, architect in the house, please take note. In front of the AC, they actually build on their balcony. There's no space in the balcony. So they install it there with a wall. There's no perforated space in the wall that the thing will eject heat out. So most of the heat is actually pumped into that balcony space. So the house girl within the house, a very smart lady. So what does it do? She knows that the place is hot. So when she washes the children's clothes and madam's clothes and oga's clothes, that is where she dries it, and it gets dry within 30 minutes. And oga is suffering inside. So you might say that one problem is leading to a good solution, but oga is suffering the impact of that. So if you must design an AC with a balcony, please ensure the wall in front of your AC are perforated or has space so that they can effectively eject the heat out. I believe I'm communicating to people. Then at the head, at the back, ensure that there's about 100 to 200 mm space behind the AC. Then if you are to mount your AC on the wall, you will surprise that the hanger you are buying from the market actually give you a particular location where your AC will be installed, with considering the space that must be behind your AC. Please, all those things are not for fashion. They are designed that will aid your AC to work well. Most AC that has problem is because their installation is poor from the beginning. And if your installation is poor, you are going to struggle all through the facility. Client will keep calling you that you guys are not doing well, AC keeps shutting down and the rest, not knowing that there was installation problem at the beginning of your AC. Then this also is the same thing like the unit I just pointed out, only that the design is different. The KSN unit is actually designed to be in your ceiling, only the outlet you see. The return air is actually coming from the middle here, while the cool air is coming from the 4 points of the AC unit. Then your ceiling unit must go with a pump. There's always a pump installed in your AC, and that pump must not go bad. If it goes bad, most of the drain water droplet coming from your AC will actually fall within your space. Then ductable unit, these are the type used in a long haul. When you say long haul, this AC actually have high static currents. When I say high static, they can push cool air to a distance of about 4 to 5 meters. All this one might not be able to push up to that point, maybe maximum 2.5, 3 meters, but this can put beyond twice as much. That's why they use them in hotel that has a long place, or in halls that have a long thing. And this is how their outdoor unit looks like. It's the same thing with the one I showed you previously, only because of the cooling required, they now double the fan that it needs to have. So we'll go to the next one. This is also another type of AC that you can install in your building. Where do we need it? Areas where you have height challenge. There are some building we go, when they were when they were designing the building, they did not put into consideration the headroom within the space. Standard headroom supposed to be 2.8 meters or and above. You go to some building, when you start installing your ceiling, you will now discover there's no space in your ceiling. So because there's no space, so these are other options that could also fit into that design. Please, when you are making your design, leave enough space, about 600 to 500 in space, because you don't know what can actually go into your ceiling. They work the same way, only that because of space, these other ACs were actually designed. They are called them fan coil units. Then we have the package units. The package units are units that have all the basic components in one place. They are installed different from your split unit. So you see the way this is installed. It's installed taking into consideration the ejecting of heat outside the house and sending of cool air in the space. They are packaged because all the other components, your compressor, your condenser, everything is in one unit. Please take there. So where can we get this? In mini supermarkets, a mall, school, hotel, hostel, depending on the level and the quality and the size of the hostel. You talk of cinema and you talk of a theater. So this is where you can see all these type of units. Then you talk about chiller system. This is how a big chiller look like. This chiller system is considered, there's what they call heat load analysis. When you want to design for a space, they do what they call heat load analysis, and there are software they use to achieve that. Then there are rule of thumb you can also use. Rule of thumb could decide to say 0.18 kilowatts per meter square. So once you know the area within that place, you just multiply by 1.8 kilowatts. So it gives you the required cooling. So when you go to the market, you buy in addition. Then when you talk of a big factory that is having a space of about 30 to 40 meters, like church, when you talk about winners chapels, you talk about all those big churches, mosques that are very big that need to be conditioned. You talk about Qatar. Presently, the World Cup is coming. There are some stadiums that are air conditioned. You don't expect them to go and be putting split units or putting a window unit or a package unit. You need a very bigger equipment that can actually take care of the cooling within that space. So these are the equipment you actually fall to. So when you look at the down part, you see the is the air cool type. Air cool type is telling you the method of cooling the compressor or the condenser. So this one actually uses water, air within the environment to cool. Then a water cool system actually use water to cool. By condenser, like your split unit, also your split unit in your house also fall within this group, because you install it outside, you need air from the environment to cool it. So you can also find a way of saying it is an air cool AC. But for a water cool is very expensive. The only people that can afford it are areas like refinery, a mining center, a very big company that requires a lot of cooling. So what they do is similar to a Lister generator. Those of us that have seen a Lister generator, we call it the Indian generator. Those one you turn and you remove the turner from it immediately. You see that there is a big drum beside it with water. The water actually goes in a component, cools the component, and the water is returned back to the tank. So there is interaction between the water and the environment, so thereby bringing the cooling. For AC, what they require in AC is what they call a cooling tower. A cooling tower actually increases the cost of your AC. That's why sometimes some people neglect using water cool type. They go directly to air cool. Air is cheap and you don't pay for it. Just allow the air to cool. And you can see that the fans are installed upwards, so they blow air upwards. So this kind of equipment must not be installed in an enclosed environment. It must be installed outdoor. This man can be installed anywhere, because you only send water in to cool it, then the hot water that goes out go back to the same system to be cool, then come back into the unit. Then these are called the absorption chiller. This cooling is different from the cooling we know. This one use a different method of cooling. They call the sodium bromide as the refrigerant. Then it actually work with a big generator. It take up heated water, move it around itself, use sodium bromide to separate it, then thereby cooling. So this one, you can get up to 1,000 kilowatts of cooling from this equipment, and they are very, very expensive. This equipment was actually delivered at one of our sites some years ago. Impact, they bought I think about two that was delivered. One of them is costing close to about between 80 to 100 million for this, as at the time this equipment was brought into Nigeria. Then this is another type you also have. They call this the variable refrigerant flow. The V is variable refrigerant flow. In some areas, you can see it as VRV. That is, VRV is variable refrigerant volume. So what did they look? They look at the disadvantages of other equipment I've mentioned below, then put it with the advantages of split units, and created a system they call the VRF unit. The VRF unit actually was designed putting in mind a DC compressor. That is direct current compressor. So those one work with a different technology away from AC compressor. So these also have capacity to save energy, they save space, and they have multiple options of indoor unit that can be installed. Even for the extension, a standing unit can also be installed with this equipment. Some of them can actually run it in a way that in some space you can create heat, in some space you can also create cooling. But the greatest disadvantage of this installation is when there is a leakage in one of the pipe. So for you to adopt this system, you must do your pressure testing of your copper system very, very well. If that is not done, you are going to have issues from the beginning of the installation till the end of the building, until that leakage is detected and installed and corrected. Please be careful while you are taking this system. Once you take it, ensure that you do your intelligent installation and ensure the unit will save. It save energy. It doesn't consume so much like the other system I've told you about. Then we also have other type of HVAC system not listed in this presentation, but are used in various sectors. Have you ever asked what type of AC are used in a submarine. Submarines are ships that can go inside the sea and come out. It's not a split unit that you have indoor and outdoor unit. There's another form of cooling used in your ships. When you go to ship, you can't install just a split unit in your ship. The sea has salt, and salt is a chemical. Each time the water touches your unit, it begins to corrode the component of your outdoor unit to the extent that it can eat all the outdoor unit up within 3 to 4 months of your installing in the ship. So they are treated equipment that must be installed in your ship. Have you also considered the airplane that you enter? You fly to Abuja, you go to Dubai, go everywhere. What kind of AC is being used in this component? Then used in rockets, rocket that launched into moon, go to Mars and the rest. Yes?
We'd like to have the 5 minute break now, sir.
Okay, 5 minutes break. Okay. Will it accompany a question or it will be later?
Later.
Okay.
Thank you, sir.
No problem. So, like I said, use in rockets. So let's say 5 minutes break will come up now. So we wait till when we start in 5 minutes time. Thank you very much for this section.
Sir.
Hello, can we continue? Hello?
Please, yes, sir.
Very well,
Okay,
sir.
yes.
Yes, sir.
Yes, okay. Just a brief. Most of the AC listed above have similar basic components. When we are talking about the maintenance, those are the components we focus more on. If anything goes wrong with one, it affects the other. If a compressor shut down, the condenser will not work, expansion valve will not be able to perform its function, then the evaporator will not be able to work. And for compressor to work, you need all the power on. The power must be good, power must be okay. Like this part of the world, Nigeria has poor power supply. So for a facility person, if you discover power is your major problem, I will advise you build two things: AVS, or your panel must be protective of your equipment. If you have a good engineer that can design a well designated panel, they can actually protect your equipment. Your condenser coil, when you are bringing in your condenser, ensure the iron and the aluminum, the coppers are not dent. They are in good shape while you are delivering. So when you are bringing it, if it is a bigger equipment, be careful not for the equipment to fall easily from your hand or people going to play with the equipment. So install it in a place. It's a bigger equipment that costs you so much money. You must build a barricade when you know the traffic of human being is much. Your expansion valve must be okay. Your evaporator must work optimally. So those are things you need to consider. Then these are your compressor. So what are compressor? Okay, compressor type. So this is how major compressor you have in your facility look like. This is a scroll compressor. So the essence of the compressor is to compress the refrigerant and bring out the refrigerating effect that is required in the building. So you see all the components, they are moving. This is a mechanical equipment. You understand? It has some things moving within it. You see a gas going out at high temperature, then a gas coming in at a lower temperature. So there's a rotation within this place that actually move it from a lower velocity to a higher velocity. So this is not for us to know, but just understand how it works. There are moving components within the compressor. Sometimes if your compressors are not okay, they make sound because there is a component that actually turns within the component. So you don't need all those names that are around it. You just understand how it works. Then these are the different types you can have in a facility, and it ranges from the load capacity they do to a very big size of the unit. You have the positive display, you have the dynamic. Under the dynamic, you have the centrifugal type, then ACL type. This one is telling you the mechanism to which those things that I just mentioned turn within the equipment, the mode to which they turn. Then we have the reciprocating type, the rotary type. You have the single acting type, the double acting type, then the diaphragm. Then we have the lobe, screw, valve, liquid ring, and the screw. So the function of each of the compressor depend on the cooling load required for the design of the AC unit. You can just have it as knowledge that they have different type. It's not for you to cram it. Then why compressor fail? You ask yourself, my AC is working, but my compressor is also failing. Low refrigerant charge. Every compressor is designed to carry a particular refrigerant. There are compressors that work with R22, there are compressors that work with R410, there are compressors that work with R407. There are different compressors. At no time should you cross-use the wrong refrigerant in different compressor. I will give you an example. Your car, you know, we have a petrol car, we have a diesel car, diesel engine, I mean. Diesel engine cannot be switched with a petrol car because the fluids have different compressing ratio. You know, you might ask yourself, why is petrol used mainly in small cars, resident, maybe passengers car and the rest? Because they have lower compressive energy. Then when you talk of diesel, they have high compressive. That's why you see that their engines are very big. They use them in trucks to carry big load, heavy weight of things, and their carbon dioxide contents are very high. So each time they burn, they bring out large sum of carbon dioxide compared to petroleum. So for your refrigerant, please use the refrigerant that is meant for a particular compressor. If you don't have an understanding, each time you buy your unit, there's always a nameplate on your unit. They will write that this unit can only go with R22 or R410. Please employ technicians that also have an understanding so that you will not go and load the wrong refrigerant in your compressor, because compressors are very expensive. Presently, they are very expensive. Then poor ventilation. I've mentioned this in the past. The way you installed your AC, you must consider air within to cool your AC. So poor ventilation actually affect the performance of your AC. And the major person that received the shock of poor ventilation is your compressor. There are some compressors that are built to be protective. Once they sense that their temperature is going higher, they shut down. Why some compressor, if you buy an equipment that are very cheap, the compressor will work till it kills itself. They work till it break down. You will see the compressor is faulty. You understand? So then block suction line. Your pipe must allow refrigerant to flow. When you are doing your installation, the standard installation is that when you are installing, you allow nitrogen to go through your copper pipe while you are installing. So most people don't do that. So they will tell you, nitrogen is very expensive. Nitrogen should be around 25,000 to 30,000 for a cylinder. So just imagine you are burning that one out. So if you are going to install units that are very massive, I've worked in a project that I supervised the installation of 1,090 split units in one facility like that. So just imagine you are going to be burning out. You'll be surprised that you will have end up using up all half of the project's money in just nitrogen alone. So most people find intelligent way of doing their thing, but the standard for a company, you must use nitrogen. And when you are coating, you must coat for it separately. Then poor power supply. I've mentioned this also. If your power is too high, it can kill your compressor. And if it is too low, it can also kill your compressor. You start hearing some humming sound. That is making the compressor to work in an unusual way. That can kill the compressor. Poor or bad installation. If you have a building that you are taking over, I will advise you, I will still talk about it when we are going forward. You must do an audit of your building so that the risks that you might take can push it back to the client. Because if you don't do your due diligence, you will enrich problem in your facility, and this will ruin your career, or probably put your company in a black light, in a bad light. Then factory problem, there are some equipment that come with factory defects. So you need to take into consideration the factory defect. Please, the person should mute. Who is that talking? The person should mute, please. Barakat, can you tell the person to, I don't know who is talking. Can I go ahead, please?
Yes, please go ahead, sir.
Okay, please. Then we have factory problem. There are some equipment that come with defect from the factory. So I've experienced that with a company, and within the same month that the warranty period will expire, the company actually exchanged this. So this gives you a decision to make as a facility manager. Where do you buy your AC? Do you buy it from the market where there's no warranty on your equipment? If it is faulty, can it be returned? AC presently sell from about 120 and above. Hardly you get AC that are 100 or 80,000 unless you want to buy fairly used. Quality AC of gig capacity are going to, there are some split units, 250, 300 and something thousand presently. And because of factory defects, you can actually return those equipment and claim new ones. Please know where you buy. Then bad capacitor. Bad capacitor can also affect. If your capacitor is not boosting the power to your compressor, it could also affect. Wrong pipe size. Every AC have different pipe sizes. It could be 1/2 inch by 1/4. It could be 1/4 by 3/4. There are different sizes. So your compressor have actually the size of copper pipe that must be installed in it. If not, you create air within your system. And if air is within your system, it will affect the compression of gas within that thing. Then for solution, ensure the refrigerant is within required standard. When you are charging your system, ensure that your refrigerant is properly charged. Then a good charging system is that when you are charging, there's a particular ammeter you must put across your cable. As you are charging, the compressor will begin to demand for current as the refrigerant is going in. So on your nameplate, there's an amperage that was written on your nameplate. It can be 3 amps, it can be 10 amps, it can be 15 amps, depending on the size of the AC. Once you get to 15 amps, that means the compressor have received the required refrigerant within the system. Providing good ventilation. Ventilation, if you provide good ventilation, you save the life of your compressor. Clear suction line. Your suction line must be clear. Your vacuuming must be done. After you have done your brazing for the indoor-outdoor unit, you must carry out what they call vacuuming. You must clear all the line of dirt, blow them out, and ensure that they are clear of dirt. Then ensure power supply or install AVS, or get a suitable panel to protect your equipment. If I will ask a question, I asked a question in one of my class. If an AC, they call you as a facility person that an AC is faulty, what is the first thing you must do? I'm not asking you to respond. The first thing you must do, you must check the power supply. That is the first thing you must do. There are some AC that are protected. Once there's power surge from their panel, the DB, there's the panel, the breaker will trip off. And if you don't know, you think that compressor or something is faulty. First of all, tackle it from the power. When you have tackled that the power is okay, you go to the cabling. Was there any place that your rodent rats has probably eaten up, or there's a breach, 2 copper pipes, 2 cables are touching themselves and returning current back to the panel, making it to trip off from the PP. You need to check all those. Once you check and certify everything is good, before you now check all that components. Then good installation. If you are a facility person and you must ensure that AC is installed in your facility, you must ensure that a good standard of installation is followed. Then ensure your products have warranty. Install good capacitor. There are fake capacitor in the market. A lot of them are fake. If you don't know the original, you will enter a lot of problem. Then use the right pipe size during your installation. This is how a condenser look like. When you open the the iron they used to protect it. This is what you see. This is how the Aldon file look like. These are the copper. Those line you see that runs straight. The one I'm using cursor to point out are the copper pipes. These ones that you see going downwards are the aluminum. Then on this side, you see that we're having the compressor, then you have the electrical parts, then you have your capacitor. This capacitor, depending on the type installed, you can have a mixed capacitor. The mixed capacitor is that the capacitor can power up your fan, the capacitor can also power your compressor. Then you have your control system there. In the olden days, we used to have only electrical connected to equipment. But these days, for flexibility sake, for remote control sake, or remote, that is, you can just switch on your remote, your AC, just by pressing your remote control. They now have to run a communication cable with your AC. AC have a communication cable. Then they also have electrical cables. Please, they are not the same thing. If you are running on big equipment, they say that communication cable does not go in line with electrical cables. It could affect communication. You understand? So please ensure you do your proper. And you see the outdoor unit is well installed on top of a component. Don't just install the AC and drop them on the floor. It also makes sense for a facility to do that. Just dropping AC on the floor. Make sure they have a base. If you can't make a whole full base, you can make some small base that you can fix it in, and make sure you fasten it with your bolts, nuts, your washers, and the rest. Make sure your AC, your outdoor unit, cannot move. Each time you move your outdoor unit, or people sit on your outdoor unit to discuss, you actually put pressure on your copper pipe. You can share your copper pipe, and refrigerant gas can actually escape from there. So this is how your condenser look like. So what are the problems associated with this? Common problem with condenser coil: block coil. Your coil can actually be blocked during installation if the depths within the system are not blown out. Because the coppers are small, those depths can actually block the flow of your refrigerant. And if there's no flow, your refrigerant cannot follow those processes I've mentioned earlier. Bent copper fin. If your copper fin are bent, it could also be a problem. You see some copper fin during installation, because the person installing does not have experience. It will press the compressor so tight that it only allows very little flow of refrigerant pipe to pass through. Those areas needs to be cut out and without the refrigerant in, and be braced during installation before you put your refrigerant. Poor installation could also affect this then leaked coil. Leaked coil can occur from poor installation, can also be factory defects. There are some AC you see, when you see oil around a particular copper pipe, know there is a leakage from that thing. You know, from the beginning, I said when you on your AC, you power it on. The essence of the electrical energy into your compressor first, and it takes up to 2 to 3 minutes before your compressor starts, is to melt that oil. So if there's a leakage there, that oil also go out with the refrigerant gas. So with that refrigerant gas, you can actually detect a leakage from a system. Solution: clear block coil with pressure washing machine. If your coils are blocked, maybe you install in a very dusty environment, make sure you have a pressure machine to wash off the dirt. And this also form part of your maintenance plan. You must have a pressure machine. There are various sizes in the market, and there are various bar. You must use a low pressure to do your maintenance. Don't use a high bar. If you go to where they do your car maintenance, you see people using a high pressure machine to wash up your car radiator. Please don't use too much high pressure for your copper. Copper is not as strong as iron. Any high pressure could actually dent it and break all those ones that are small. Ensure the fins are not bent. When you are receiving your equipment at first, be it big unit and the rest, ensure that the fins are well straightened, not bent. Then ensure good installation at the beginning, then block any leakage. If you discover any leakage before you put your gas, discover leakage. Some of the problem people have called me, Mr. Juro, I discovered that there's a leakage in our AC that we keep topping. Keep topping refrigerant gas, an AC system is wrong. You must look for the source of the problem. Just like in your building, you have your pipes running. Each time you fill water in your tank, You will come back in the evening, there's nobody using water. You discover the whole water have leaked out. Are you going to just keep pumping like that? You must identify the source of the leakage, block it before you continue. Then this is an expansion valve. This is what an expansion valve look like. So you have something that are thin, very thin. You have an inlet. You see the inlet, you see the outlet. The essence of this component you are seeing look complex is to reduce the pressure. Cut the story short. And this is how it look like. It's mainly in bigger equipment. In a smaller unit, there's another version in smaller equipment. The essence is to what? To control pressure of the refrigerant gas so that they can attain what they call the refrigerating effect or the cooling effect. Then common problem with expansion valve, poor installation, poor phase change from compressor. If there's a poor, when I talk about phase change is, the refrigerant gas sometimes act like water or liquid. If you check your gas you used to cook at home, when you shake it, you will be feeling as if there's water inside. At the top, there is gas. Your refrigerant gas also act in the same manner. So sometimes when it is being compressed, it is compressed and changed from that liquid state to a gaseous state. If there's no proper change of those phases, you will not be able to go to the next stage and achieve the cooling effects required. So good installation must be ensured. A proper phase change, a proper expansion valve will ensure a good phase change is done. Then fake TSV, there are a lot of fake also in the market that will not last. If you go to China and the rest, most of our people bring all this fake thing into Nigeria. Once you install it, you see that the thing will just knock off your system. Then solution, good installation. You see, my engineers, my facility managers, my architects, and everybody in the house, my land surveyor and the rest, everything I've also mentioned has revolved around installation. If installation is done properly, your budget for maintenance will actually be less. The repairs on your AC will actually be less. So put more emphasis on good installation. If you are to install in your facility, if you are in charge of a project and AC is to be installed initially, please put good emphasis on good installation. Most of the poor equipment you see in building as a result of poor installation. When you are trying to cut on budget, you bring in quack people. Because you are cutting on budget, they do nonsense in your building. At the end of the day, they will definitely go. The cost you are trying to save, you will pay back to other people. Thereby, it's not a problem. You create employment for your technician that will be making money from you or be making money from your company. Then proper phase change from your compressor. So once the TSV is properly done, that phase change will definitely connect well with your compressor. Then use the right components. Use the right TSV for your system. Then your evaporator coil. This is how your evaporator coil look like. It look exactly like your condenser, but their principle looks similar, but they work different way. Your condenser actually ejects heat and receive cool air. The opposite is done by your evaporator. Your evaporator send out cooling and receive hot air. Please don't forget, they work in opposite way. And this is how it looks like for the split unit. Then for bigger unit, this is how they look like. There's always an inlet, there's always an outlet. So for this copper, it could be a refrigerant going in here. There must be in and out. That in will be going at a cooler temperature. By the time it comes out, it will pick up the heat passing through it. Then the temperature will increase. It will now go out to the same place. The same principle is this same outdoor unit, indoor unit for the evaporator on splits. Then common problem with evaporator coil. Your evaporator coil could actually be blocked. Why can evaporation coil be blocked? When you have units that have not been maintained for 1 year. If you check most of us here, to be sincere, you'll be surprised that some of us don't maintain our AC. And the AC has been there for years. We have been using it. If you go and open that AC, you'll be surprised that the evaporators are blocked. And the simple way to discover evaporator is blocked, you start seeing ice forming on it. I will explain something to you here. You can use that to do analysis. The temperature for refrigerant can be as low as 75 degrees. So when hot air passes through it, that that hot air mixed with the cold temperature to bring the temperature at 28 in your room to maybe 22 or 25. If there's a blockage in your coil, that principle I just explained will not occur. The cool refrigerant will keep accumulating on top of the door because the doors will not allow the hot air to come in. So all the air around the evaporator will start forming ice. And in forming that ice, no movement of hot air will go. That's why your AC will work and still not cool, because there's no movement of hot air through it. Please take note of that principle. Low refrigerant can also affect, just like your compressor, your condenser also. Then faulty fan. If everything is working out fine and the fan is not blowing, it would not supply the required cooling. Then gas leakage from its coil. The coil can also, if there's a dent during maintenance, the person that maintained, when he was maintaining, he want to do the work alone, the evaporator fell from his hand and hit the floor. There could be a dent in the coil. And if there's a dent, there will be a leakage. It takes the grace of an experienced person to actually detect the leakage in evaporator, because the unit was built to be very compact, so it will be difficult to detect. So factory errors could also be a problem. Then solution: clean or pressure wash the coil. So if you discover your coil is blocked, you need to pump down your gas into your outdoor unit. After you pump down, you must disconnect your copper pipe, the suction and the liquid line, or disconnect your electrical power supply, then bring down your indoor unit, take it outdoor, then use pressure washing machine to clean off all the debts and bring it back inside. Ensure required refrigerant is used. Don't go and use the wrong refrigerant for your pipes. If you use the wrong refrigerant, because of the high pressure within the system, it could actually rupture and leakage will come out. Ensure fan is working as required. Seal off the leakage gas. Before you seal off this gas, make sure you pump down. After you pump down, ensure the gas has escaped, or you recover the refrigerant gas before you start breathing. There was a guy that was actually discovered there was a leakage in the system. Quack as he is, he did not check, follow all the safety precautions. He went ahead and on oxygen and acetylene, plug it together to bring out that blue flame and put it in a system that has gas. There was a large explosion. This guy I'm speaking did not survive that explosion. Please be careful while you are maintaining and know who you call for your maintenance. Make use of your warranty when you discover after your troubleshooting and checking that the problem with the equipment is actually from sale. You return it back to your buyer and get your equipment back. Then filters are the simple thing that clean up the air. After you have cleaned up your house, the next thing that clean your air are the filters. And these are the kind of filters you see in your indoor unit, and these are the type you see in your bigger unit. Some of these bigger units can have this in 4, 5, 6, 7, depending on the size. But the basic principle they follow that once they are blocked, they need to be washed. This one can be washed with your ordinary tap. You sieve it out, dry it, then install it. Then your filters too can be washed. And don't forget, there are different types of filters. There are disposable filters. Disposable filters must not be washed. By the word disposable, you must throw away. There's a washable filters and there's a hyper filter. And these filters, they clean air to their own capacity. The best of all the filters are the hyper filter that can clean air, clean to 99.9% free of dust. This other one that are the washable type can clean air up to about 90, 80%. Then the disposable type, they can clean air up to 95%. But the problem with that is that it will increase your consumable. So most sites, for a bigger unit, we prefer this washable type. Once we wash, we return back. So some people are already raising, okay, sorry, question. So common problem with filter: block filters, poorly installed filter, low quality filter, using wrong filters. Everything about filters is centered on filtration. It can also remove some microorganisms from air. Filters, they have a lot of work to do in the system, because as you are cooling, the air within our environment is polluted. Some has smell, some has all kinds of deaths within it. By virtue of filtration, it reduces that effect on your staff, on yourself, and your environment. So the solution: clean the filter regularly through maintenance, install filter properly or as stated. It's supposed to be as stated in your operational manual. Then use the recommended filter. Every unit has their own filter. Don't go and use your split unit in a bigger central system. They have their different filter. Then use the appropriate filter for your system. Then water leakage. The other problem you could also discover in your AC is water leakage. Water leaks from two options: either from your drain pipe or from your evaporator. Your evaporator is due to poor maintenance, ice forming on it, then water drops. So as AC is cooling, water actually drop from AC. So they have a place where the water could actually drop and it will follow your pipe out of the building. Then when you are running that out of your building, ensure you don't end the pipe where there's smell, because smell can actually follow through those pipes into your building and pollute the environment. Please ensure your pipe has what they call a U-trap. The essence of the U-trap: you have some water still within the system while others are moving out of the system. It stops rodent coming in, it stops cockroach coming in, it also prevents smell coming into the space. So ensure that your units are well maintained to reduce the sweat. Then ensure your drain does not have a backflow. Install it well. And if you must install at a length of about 3 meters, 4 meters, 5 meters, ensure you have a air vent at about 2 meters or 1.5 meters, depending on the distance that the water will take out of the building. At no time should you run your drain running about 5 meters, because air can actually be trapped in that thing. And if air is trapped in your pipe, because it is smaller, it will cause backflow into your building. And that backflow could actually create mold growing on your wall, and it will deface your wall. Then problem: structural defect. If water is flowing into the wall, it can cause structural defects. It may result in smell. It may result in mold growing on your wall, growth of algae, backflow of water. Would also, once there's a problem, solution: good installation, proper installation of drain line. When the drain line is installed, ensure there is a water flowing out of the building. Install drain exit away from gutter or smelling environments. Then eyes on condenser coil. These are some of the problems I mentioned below. If there's no proper heat exchange here and dirt is blocking it, because the cold air is not seeing where to interact with the hot one, eyes will begin to form on your coil, and this will now make this coil to look like a plank. A plank does not allow air to pass through it, thereby killing your compressor. So ensure proper maintenance. Poor cooling will result. It can lead to compressor failure. Efficiency of your AC might be affected. AC is working but not cooling well because of that blockage. Clean block surface with a pressure pump. Then place your AC on PPM. Ensure that the AC is properly maintained. Install AC in clean environment. Remove every source of blockage that you notice. Sometimes when rat is trying to force its way through your drain, because you didn't do that U-trap, you could actually die in within your pipes. And if you die, it can also cause backflow into your building. This is how a capacitor look like. A capacitor have a common point. That common point can be shared by these two components. This is going to your compressor, while this is going to the fan. This is how a capacitor look like. So the capacitor is a commonly found electrical component in a variety of gadgets and equipment you use. In a nutshell, the capacitor regulates or provide enough juice. When I say juice, power needed for certain parts of the appliance to function. If capacitor is not in your system, the AC will not work. So the work of the capacitor is to boost energy to your compressor to start. That is the high starting current. Then the compressor will now go back to a normal current when you are starting. So that is that about capacitor. Then problem, poor power supply, fake capacitor is in the market, then undersized. If a capacitor is stand to be 35 UF, if you are replacing, ensure you replace with 35 UF. Don't buy any value higher than that or less than that. Then solution, the solution, you must check your capacitor. The solution for your capacitor, ensure you use the right capacitor. Click sound. Sometimes you hear some sound when the capacitor puff while they are working. So when you hear that, make sure you replace with the right capacitor. Then the air conditioning units are trouble starting, but keep running off. Visual side, these are ways for you to detect and replace with a good power supply. Fake capacitor must be replaced by the good one. Then undersize must use appropriate capacitor. These are ways you detect problem within the capacitor. I think this should be some error from my end. Then ensure that if you want to detect the problem with capacitor, you see that the capacitors are swollen. They have overworked, probably by over, maybe the power supply was too high, maybe power surge could allow them to expand. Once you see that expand, you could actually change. Sometimes it bursts. Once it bursts, then you need to replace. And there are some that will not show any sign. The only way to do this is to use your multimeter to check that the capacitance is within. And if the capacitor is 35 and you are measuring 30, please replace. Don't use it. It will not keep the compressor working as required. What are the things you look out for when buying HVAC system? Sometimes you ask, sir, I have done the AC well. What brand of AC must I buy so that my maintenance culture will be within standard? Please, brand of air conditioner system matters a lot. Some will tell you Panasonic is the best. Some will tell you I like LG. Some will tell you the choices of brand depends on your pockets and depends on your experience. Please take note of that. Type of refrigerant use. Presently, we are being encouraged to move from R22 to R410. If you want to go to the market, they'll tell you R410, and R410 are quite expensive than R22. R22, because of the greenhouse effect and global warming, people are moving out to a bigger and a better refrigerant. So based on environmental friendly, we are being encouraged to use R410. Warranty period on the product. Before you buy, ensure the equipment have warranty. Then consider the energy efficiency ratio. Energy efficiency ratio is telling you that this is the equipment. I need just little power to gain maximum output of the equipment. I want cooling, but the energy should be small. Now, most units are now working towards that line. Most of our, if you look at light now, you have energy saving bulb. You have energy saving this, fuel efficiency. People are going to little application of energy and maximum output. So based on that, if you have the higher the EER, the more efficient the equipment will be. Aesthetic of your building, you want to you have a high-rise building. Definitely you should go for a central system, a VR system. At no time should you go for a split unit. And if you must go for a split unit, make sure where the outdoor unit will be installed should be considered. Most of the building that you want to do maintenance, you see that ACs are installed on third floor and installed on fourth floor, and you need a very long ladder to get there. Some people can actually fall and your AC can fall from that building. How much is the service? Then somebody dies in your facility. Please, you must consider aesthetic, and for the architect, ensure that proper balcony with perforated wall are installed in front of your AC, and you create enough ventilation. At no time should you create a AC that you have to go to third floor with a ladder to do maintenance. You have to rent a ladder, you pay for the person, then if there's any damage, you pay for it. You end up spending close about 20 to 30,000 to service just one unit. Please consider that. Then your budget could also matter. What is your budget for AC? Can you afford a central system? Can you afford a VRM system? Can you afford the split unit? Can you afford the window unit? So the budget depends on your decision between yourself and your client. Purpose of the HVAC system. There are different kind of HVAC system. Where can we install? The HVAC system used in a factory is different from HVAC used in a hall. HVAC used in a library is different from the one used in a nightclub. Nightclub, they dance a lot and the rest, so they need a more rugged and a high cooling equipment so that when they talk, you will understand that they will not sweat. Each time I watch TV and I see people presenting in an enclosed environment, I always look at their head. When you see some reflection of the light, know that there's no AC in that building. Or if there's AC, so matters a lot. Then maintenance of your AC, you must consider it. Can the AC be maintained? Don't go back and buy an AC you cannot maintain. Then the critical component you can also consider. Hello, can you hear me? Hello?
Yes, we can
Yes,
hear
very
you.
clearly.
Okay, please.
Yes, we can.
Yes, then all the other thing you need to consider in your AC, availability of spare parts. Most of us love American brand, but when you finally bring the American brand here, can you get part for it when it is faulty? You must have your question. Ask that question. Most high-rise building in Marina have abandoned using central system. You can confirm from some big architects, consulting firm, because the maintenance is high. And if you ask the company that installed it how much to buy this part, you'll be hearing 1 point something million, 3 point something million. To buy parts, how much is the equipment? Then looking at your budget, it will shoot up your budget. People that can actually afford all this, like Mobile, Shell, Chevron, what they do, once they buy an equipment, they actually ensure that they buy them with parts. They always have stock of parts, and each of these equipment have what they call part number. If you want to buy an equipment from the US, they will tell you, please, can you give us the part number? Part number is used to design a particular part. Once you give it to the engineer, each code in that part number represents something that you don't know. Please take consideration of that. And this particular maintenance also form your decision whether you have to use the people that install to maintain, or you look for an experienced person to do your maintenance. Please, these two last things, you must consider them in your building if you must succeed. Then what are the possible causes of HVAC failure in a facility? I've told you, this is the summary of everything we talked about. Poor installation, poor design, wrong HVAC system. You went to carry a chiller for a 2-bedroom flat. How do you power it? Don't you know for a chiller, you will need a 3-phase system to power it on. And if you must rely on Nigeria PACN, 3-phase are not always complete. You have to buy a very big generator to power it on. If you see some company, now that the price of diesel have gone down, you see that our people are doing load shedding, even for big banks. Now I heard that Sterling Bank has been able to use solar panel around the building from top to bottom. I don't know if that is working well. It's something we need to emulate in some of our building. We can actually use solar to power most of our building. You can actually use it. Then you could actually reduce your power consumption. If you live in an area that you use meter to measure your power supply, you can actually own your AC. Instead of your AC to run 8 hours during the day, you can actually run your AC for just 6 to 4 hours. You put them on timer. It will work for about 10 minutes and shut down for 5 minutes. So those time you are saving could have direct impact on your cost. Because if you pay NEPA bill, you'll be surprised some NEPA bill in some facility are running into millions. So if you put those little things I'm telling you, you can save costs for your company and you'll be given an award. Then you also take note of oversize and underside. If you overside, you are paying more for power. If you underside, you are discomforting your staff or your occupant or your client. Not taking into consideration the actual cooling load. People sometimes they just say, go and buy 2 horsepower, go and buy 3 horsepower without considering the load required. Please take note. The building in Lagos of the same size is different from the building in Maiduguri. Maiduguri, their outdoor temperature is very high. If it is not close to 40 or 40 something. But in Lagos, our outdoor temperature should vary between
Wow.
to use 30. I always use 35 for my load design for Lagos. For some other places, you use 40. For those that does design, also consider what they call redundancy in a building. Redundancy is mainly for server room. When you have a load in your server room, after your load selection, you determine that it is 20 kilowatts. that is required, don't put exactly 30 kilowatts. So the excess kilowatts would actually occur when one of the units in the server room fail. You will just on your redundant equipment to cover for the AC to get the server room cool before you actually fix the problem. The other one you could also get is poor installation, then poor maintenance culture. If you are in an environment you don't maintain your AC, you could also have problem. Purpose of your design is not defined at the beginning. No available parts, not considering power issue on your problem. Then two procedure that you must carry out for. The other thing you need to consider is constitutional assessment or audit of a building. That also matters a lot. Two procedure we have to do during all this is preliminary audit, then detailed audit. So when you talk about conditional assessment stroke audit, you are going in to assess the condition of the equipment. And once you have defined the condition of the equipment, you begin to identify the problem, propose the solution, then do a budget. So you could draw an Excel sheet, maybe for your AC on first floor. Identify when you are doing an assessment, okay, split unit, the capacity is this. What is the problem with unit? Electrical cable is faulty, it's not cooling properly, then last maintained 2 years ago. You state it, then you put another portion. What are the possible solutions? Ensure the AC is on maintenance, change the electrical cables. If there's any damage one, then you put the problem. Then what are the budgets? You will have called either your technician or a company to come and give you the cost for the ACs. Once they give you cost, based on that, you will now raise the budget and forward to your client. Two things will occur from your clients. Your client will tell you, but you just came, you're already asking us for money. You want to finish us? So please ensure on record you have sent something to them. So when you are doing your inspection, you must use virtual inspection, check for any physical defects. And if you cannot see the defect, use either electrical measuring equipment or any other tools that can aid you to take a better judgment. Then you can also make references to the manual of the equipment too. Then these are the things the action plan you must follow when you are carrying. Hello, can you hear me? Hello?
Yes, sir.
We can hear
Okay,
you.
okay.
We can hear you, sir.
Sorry, I need to ask because network is fluctuating at my end. So these are things that you must consider also when you are doing your audit. Checking the envelope used in the structure, that is the building envelope. Then this one, visual inspect the plant. Then check for the pressure or O&M activities and contract. Then considering the list of energy conservation opportunities, you list then flexibility need for details, activating the details of audit and the rest. So you follow that same pattern or you draft your own pattern. Then step required for carrying out the gather building design data. That means make references to the document. There's some document that the maintenance plan is giving. So you can extract that one out. Then visit the site or the location for the audit. You must go to site. Don't wait on somebody calling your phone that this is what he has observed. Definition of a profitable solution and action. Then reporting. You must look at what you guys are looking out for. If you want a professional job done, you do your audit, like I said, identify the problem, the solution, then put a budget. Then the budget is the action plan. Then your reporting can contain every other details you feel that the client will want to know. Then there's what also they call a checklist. Checklist is what your vendor might use or you derive one for your guys on site. What do you do for your checklist? You write things they must check on daily basis because you don't want the thing to fail or you run into emergency. You derive a checklist. Check your cables, check your compressor if there's any sound, check if there's a blockage in your evaporator, check if your pressure within the system is okay, check if there's any rodent going into where the cables are installed, check if that water flow is going out well. Before your client calls you, you already know what the problem is. That is the essence of the checklist. Based on the checklist, you can also rate the performance of your guys. There are some checklists that actually have time that your guys must fix some problem. Once you check and you detect the problem, you tell it to change a filter or do maintenance. On each unit, you spend maybe 30 minutes for maintenance. So that will now gather up to calculate the time your guys need to maintain. If they fall short or fall above, you can now take your judgment on their performance. Plan preventive maintenance is what I've stressed before. Please, I'm stressing it again. Maintenance allow you to substantially reduce reactive maintenance. Retain your building and asset at a desired level of quality. Time-based preventive maintenance is based on a fixed execution frequency of activities that generates a calendar schedule. I've mentioned some of these earlier on, but please plan preventive maintenance. You must plan it and make sure you prevent any failure that will come. And then this is another summary of what I have still rounded up to give you on preventive maintenance. Please let us adopt this particular method. This on plan type, please let us just know it for knowing sake. Please don't adopt it. Then you can also use some software within your phone. Those of us that can have, you have board within your site, you have an office, you can actually make a design. This, what I've given to you here, contain different assets within this particular building for this person. So you can list it out. After I list it out, you put the prepared by the person or the person that is supposed to take the maintenance. Then one other thing you can also do, you can also put the person's phone number. Then you put the time to which they must carry out this inspection. Then ensure that you put time in. You can do this Excel sheet running from first week to, we have 52 weeks in a year, running an Excel sheet. Then put the date that the maintenance will be carried out. For your maintenance for 1st of January, you know that the next maintenance will be when? January, February, March, April, in what? After 3 months, January, February, March, April. The next maintenance will be 1st of April. So you use a color code to determine that on your maintenance plan. You go to your generator, you use another different code to identify this, then put the person that will do the maintenance. It can be your vendor or your staff. Then put their phone number in case and place it on the wall for all your staff, a common place where people can see. Even when you are not on site, you already know. Then if you must use your calendar on your system, you need to put a timer. You can even use your phone. Put your calendar, structure it in a way that it can give you 1 week reminder. Please, your phone can pop out that our maintenance plan for HVAC is for next week. Please call so number. So you can program it like that. Then if you have money, there's a software they call eCafem. They are expensive, but they are very good. These are a quick automated system linked to your equipment. So once the maintenance for the equipment has reached, the software by itself sent a mail or a text message to you that the equipment is due for maintenance, which is a very standard way of doing. Whichever system you propose, you must monitor it and ensure your equipment is working optimally. Then the other thing I've added also, you might ask, what are the things that add heat into space? What add heat into space are human. Okay, this is just the diagram of how your office space look like. What add heat into space are human, electrical equipment in operations, lighting system generate heat, solar heat gain. When I say solar heat gain, the location of your building to the sun also add heat to your building. You might ask, how do that have to do? If you park your vehicle under the sun, what happens when you open it, when you want to go home? You see the volume of heat that it has gained. So your wall too can gain heat. So in doing that, you ensure you use window blind at your window, because once heat is coming, most especially if you have wall, your wall throughout your building are glasses. Glasses absorb heat. In order to reduce that, you can use window blind to reduce the heat coming into the building so that the AC can only take care of the space that is supposed to cool. Then location of the building also matters, whether in Maiduguri or Lagos. Activities carried out within the place. Is it a church? Is it a library? Is it a court? Is it a court? Is it a nightclub? And the rest and the rest. Then AC, these are tips for AC installation. Your guys can actually use this. Strength of the wall. Before you install, you must consider the strength of the wall. Proper spacing between the walls and the AC unit must be ascertained. Appropriate installation height from the ground. AC must not be installed where children can get access to. So that's why you see most AC are always close to the ceiling. Then correct tinted angle of indoor unit. You must tint it to a particular angle where water can flow out. Correct location of outdoor unit. Outdoor unit must be located away from where sun rises. If sun rises where you install your outdoor unit, it have direct impact on your AC indoor. Proper placement of outdoor unit. You must install it not bent, must be properly installed. Right distance between indoor and outdoor units. Use the proper electrical cables. Nigerian cables are the best. Please, I implore you to use cable. The minimum required plug for your AC is 15 amps. Don't use 30 amps. 30 amps can work for smaller unit, but sometimes if there's a power surge, fire, because there's a high demand for current, they could be fire from your electrical component. Most fires I've seen and I've known actually occur from HVAC system. Then do proper vacuuming of your AC. Ensure there is no leakage. Use proper refrigerant, then ensure your thermostat is well installed. Then different type of AC installation you may find in various buildings. You see what this man is doing. You see the proper installation. You see that they install where they can use your A ladder to achieve. But beyond this particular floor, you will need that straight ladder used by NEPA to get to that equipment. I've seen a guy climb a ladder from a 2-story building, putting the outdoor on his shoulder, then bringing it down for maintenance. If the guy has not eaten well, I can assure you, he will land with the AC on the floor. Then this is another type you have. If you are in a supermarket and you want to use your space on the ground floor for parking, you can actually move off your AC to the roof and create an entrance into your building that the refrigerant pipe can go out to a different floor while you're installing. Then you could also consider this might be a supermarket. Why you have this kind of units are people that want individual control of their units. They are the one paying for the units. You understand? So for this to solve this problem, you just need a central system. Once you do your central system, it's all solved. Then this is some of the AC units that are actually delivered to BATS, that is British American Tobacco, in Ibadan some years ago. You see what we did here? We ensure we created a plinth, a platform where the AC can be installed. We didn't put it on the floor. Once you drop this thing on the floor is irregular. So when you are doing your installation, your pipe will not stay well where you are doing your installation. So it must be put on a well-tinted place. Then don't forget, before you drop, there was they call a vibration pad that must be put at different points in this thing, so that when there's a vibration from the equipment, it will not transmit it into the structure. Then this another unit, VRF system on top of the roof unit. These people maximize their space on the ground floor by taking all the unit upstairs. But the problem with this system is identification. We've had problems where you send your technician when somebody called, maybe in third floor, that my AC is not working. Because there were no proper tagging, the guy went to cut off a copper for first floor that was working, and the actual problem is on second floor. He has created two problems. So what you can do in this part, there are tapes that are blue, red, yellow in color. So the equipment, you can put yellow there. Then all the pipe that runs through that yellow to that floor, you use yellow to indicate them. Then for another floor, you can decide to use blue all through. So that aids your decision while you are troubleshooting for any problems. Then these are your split unit. This is how the split units look like. This is your manifold gauge used to check the pressure within your system. It can also be used to charge and also be used to remove gas from your system. This gauge is more like what our doctors use to check our heart, whether our heart is having the right beat, or your pressure, your blood pressure measuring machine to check whether your pressure is within. The gas has its own. This is what they call it. So you see the indoor and outdoor unit. Where this man is holding, where his hand is touching, is where you actually charge. This place, you use a key called Allen key to either lock or open the gas to go or to lock. When you are pumping down, one side of this must be locked while the others is open. So once you lock, two people must be standing, one outdoor, one indoor. Once you have locked the gas at one point, you tell the other guy to on the system. As you are on the system, all the refrigerant gas in the system will be withdrawn into the compressor, and immediately within 20 seconds, 10 seconds, you shut your system. Thereby, you have saved this. Then you can now lose your refrigerant with your spanner and the rest, and detach this when you want to do your maintenance. Do your maintenance. Then the other thing we want to speak about is ventilation. Ventilation is also very necessary. People are waiting. So ventilation is the process by which clean air, normally outdoor air, is intentionally brought into a space. You know, if you go to the village, we have a standard way of ventilation. You see people when the building is hot, they sit under the tree. But in Lagos, we don't have tree everywhere. We have to buy standing fan or ceiling fan. So when you are on a fan, you tell, oh, yeah, open the window while the fan is working to bring in cool air. So you are intentionally bringing air from outdoor to cool yourself. It could be air movement within the space to cool yourself. That air, that ventilation also serves two purposes. One in the kitchen, one in the restroom. Why you have Mr. B's and all the eateries cooking within a same space where food is being served is because you are using fan to move out the smoke, smell from the kitchen out of the building through ventilating equipment. So ventilation can also be used to control movement of air within the space. There are some buildings that are standard. When I say standard, they use the ventilation to control movement of air. And this ventilation, you hear building that they will tell you is pressurized. Pressurized building can also reduce fire impact on a building. There are some few buildings that have this pressurized system. The essence of pressurized system is to reduce fire and control the movement of fire within a space. You understand? So ventilation has a lot to do. We have what they call mechanical ventilation. We have what they call natural ventilation and fixed mode and ventilation. The essence of mechanical ventilation is that we are using equipment like a fan to get the ventilation. Natural ventilation is that through architects, there are some ways they design a building where that they design them facing the direction of air coming into the building. So by doing that, you see that air come into the building without any assistance of any mechanical design. Then the mixed mode is that there are some area you allow the mechanical to come in, you allow the natural to come in, then you force the ventilation to move the air. Then these are the sample of fan that you can use for ventilation. This is a centrifugal fan. You see the way it takes in the hot and it takes in the cold air out. They can also use to cool. So the only thing that moves there is your electric motor. Once you energize the electric motor, this thing begins to turn. Then it sends in the exhaust. Then you see the intake air coming through that point. Then these are some AHU that have this kind of formation. Then the AHU have what they call outdoor air, then economizer, the mixing bus, then the return air. They have their function. The OA is outdoor air. Outdoor air, why you will need it indoor is because it has oxygen. Sometimes you'll be in a building, you say, man, this place is stuffy. What do? You open your window. The essence of opening is to allow oxygenated air to come in. The return air are actually the air within the space that have been heated up, full of smell and the rest that needs to be sucked into the building. Then you have a heating equipment. That heating equipment is where you want to control the humidity of the space. That is when you put this component in the installation. But if you don't want to control, you can only use the cooling equipment. You use this. Then when the cooling is achieved, you supply through a duct line to the areas where these things are needed. Then ventilation is needed in the kitchen. Why do we need ventilation in the kitchen? You move smoke out of the kitchen and smell out of the kitchen. If you go to some kitchen, you see that there's blackish substance on top of the kitchen because when you are frying plantain, you are frying your chicken, the smoke remains in the kitchen for a long time because there's no movement outward. The kitchen looks very dirty. There are some high-rise building on the island I've visited. If you enter, the kitchen is looking sweet because they use ventilation to move air and smoke out of the building where it is not needed. It is also needed in the toilet. Sometimes when you go to pool, the pool can smell so terribly. So what you need to move those things out is ventilation. You use what they call extractor fan. When you are extracting, make sure you are supplying hot air in, cool air into the space by opening your window because nature does not allow vacuum. You get my point? Then different kinds of air. The air type we have return air, heated, then you have exhaust air, then the outdoor air. Then fresh air units, fresh air supply is air coming into the space. Then we have exhaust air. The exhaust air is heated air going out of the building. Then we have air handling unit. Air handling unit are in bigger equipment, and their functions are different. Their functions aid us to condition the air into the quality and the dimension you need it. You can actually control the air within your air handling unit. Actually handles the air within the space. So there's filtration. There's the once I show you up, there's an area for filtration. There's area where the cool air goes in. There's area where the thing goes out. So this is a cooling curve, fan, economizer, heat recovery in those equipment based on what you are selecting. A small investment on your air conditioning system, prevent maintenance or servicing, offered multiple benefits. A well-maintained air conditioner perform better even when it becomes old or might work beyond its lifespan. Users should consider spending a small amount now on preventive maintenance service instead of wasting a lot of money on repair works or replacement after the damage is done. So I thank you very much. The end of the class. Hello. So question time.
Thank you, sir.
Thank you.
So question time. Those of you that have questions to ask, this is the opportunity. Just indicate.
Yeah, I have a question.
Okay, please go ahead.
Hello.
Go ahead, I'm listening.
Okay, well, I'm Akim by name, and I'm an engineer as well.
Okay.
I noticed in one of the building I'm actually working on, although we actually I'm representing my company as the owner of the building, whereby we gave it out to a contractor.
Okay.
So in the installation process, where they bring in the copper to install, like kind of install before providing the outlet for the AC. I noticed the copper, what's it called? The pipe.
Pipes, yes.
They are not as long as they are not that long. So they do it in a very short kind of connection. And I was wondering, like, okay, if this thing is as short as this, when they finally bring in the AC, so how are they going to try to screw the copper pipe to the outlets? I mean, what's it called?
You are talking of the distance between the outdoor unit and the indoor unit. Is it a split system? Is it a split system?
It's a split system.
Can you give me average? What is the distance between the two that you observed? What is the distance?
No, what I'm saying is the AC has not been installed yet.
Yes.
They just provide the pipe, like the connecting pipe between the outdoor and the indoor. So what they left outside from the wall to that pipe is just like 200 mm.
Wow.
Some is not even up to 1 feet.
Wow.
So I called the attention of the contractor because we have given him the job, and I am representing the client. At the same time, I'm the organization site engineer. So I called him, I called his attention. So, and he said they are going to work on it. Until now, they've not worked on it, but I'm just waiting for how they want to install all the ACs, because he's still the one that's going to take care of that.
Okay. So what I would advise, the standard distance between indoor and outdoor unit, maximum size is about 12 meters. 12 meters. Probably what they try to do, probably the areas that will give them obstacle, they just install some copper pipe there. They want to brace to connect to the indoor unit. Then if you have a drawing, if you can analyze your drawing well, try and see where the outdoor unit is located, then the indoor unit is located. Try and find out the distance required. If they are not still yielding to your suggestion, please stop the job. Stop the job, because most buildings have gone to, most of the problem for maintenance actually occurred during installation. And if your care is not taken, you don't want to have your client in and you'll be telling them that you want to do some remedial work on your AC for a new building, then it will mark the value of your property a little bit low. You know, people go around, that building, the AC in that building is terrible. They did a very bad job, as they are saying that the value of your property is going downwards.
Yes, actually,
you
if there
understand?
has been a drawing for the AC installation and all the mechanical, but the mechanical drawing for the ACs is not actually provided. So,
if it's not provided, you can work. I've given you an example.
Yes,
we can
yes.
After this, I will drop my number. You can give me a better picture. You can snap what they've done so that I can give an advice.
Okay,
so
sir.
let's leave the room for people to ask.
All right, thank you, sir.
Please, I'll drop my number for you guys to call me if you
sorry
have.
for
Yes.
coming in, sir. Did you say the standard distance between the outdoor and the indoor copper pipe should be 12 meters?
Yes, 12 meters, sir. Standard size. So if it is beyond that, it will work, but the efficiency of the unit will fall. I will give an example. You are on one-story building using a 1 horsepower pump. You now, by mistake, you now converted a one-story building to a 3-story building. You now run your pipe up, and you still want that 1 horsepower to run that pipe to 3rd floor, supplying water. My brother, you are overworking that water pump. So your compressor also work like a pump. So if the distance is too long, it will have to do a lot of work to overcome the heat, the refrigerating effect it needs to supply. So that's the essence of distance. Not that it will not work, the efficiency will drop, but the solution is that there are some buildings you cannot do without that little distance. So if you must use 1 horsepower and you see that the distance is going to 15, I will advise you buy 1.5 instead of 1 horsepower, because the compressor is now bigger. So the compressor can now overcome those challenges and give you the required cooling. Next question, please. I was told I have 10 minutes, so let us make it snappy, please.
Hello, sir. Hello, good evening.
Yes.
Good evening, sir.
Good evening.
Good evening, sir. I want to ask the question of you are talking about for VRF. How do we determine the return and the supply? Take for instance, when I go to spa, I always think, how do they get the supply and return? How the numbers? How do we calculate it for a bigger size?
When you say return, is it for the discharge into the space, or you are talking of copper pipes?
Yes, for the discharge and the return. For the discharge and the return.
Yes, return is always return is calculated about 20% of the
20%.
duct. If you know how to size duct, you do 20%. Okay. There are different ways to do return. Either you use ceiling return, which is the cheapest form of return because there's no duct. The AC is installed in the roof. So there are openings created that will take the hot air going into the ceiling, into the room where the ASU is going to work and supply. So just leave perforated place. If you calculate your roof to be maybe 1 meter by 3 meters, just calculate the area, that is 3 meters square, then calculate 20% of it. You might even remove 2 ceiling ties and put perforated ceiling ties at 2 different points. So all the hot air will find their way into the space. But for a bigger unit or a ducted unit, ensure that the return is exactly at the back of the unit for ducted unit, while the supply is at the front. You might not be able to picture what I'm saying. It's what I've installed, I've monitored. So return, there must be movement. If there's no movement, once you are supplying, there must be return. If there's no return in a place, you are over pressurizing the place. It's like you are blowing a balloon without air going out of the place. Please take note.
Okay, sir.
Then
thank
for
you very
further
much.
this, if you can, I will drop my number. We'll talk after that. Then
I will appreciate that, sir.
Next question. There's a lady that wants to talk now.
Hello, sir.
Yes.
Good evening, sir. I want to quickly ask a question on the refrigerant gas.
Yes, go ahead.
For a new silicon seal AC, split head AC.
Yes.
How long is the duration of the gas in the AC before you change or before it's finished?
A gas if this AC is fully and well installed, it does not leak.
Yes.
It does not leak. So if it is installed like that, the duration does not come into place. It will work till it dies. Where you have some leakage, probably somebody came to do maintenance and tampered with something, and there was a dent along the pipe, then the gas started leaking. That is where most of the problem comes from. When we start having people that are not good in maintenance and they come into our building, they create more problem for us. It is wrong to top up gas. It is wrong. It's just like you not having blood in your body. You not start topping up blood. You have to look for the source of the problem and solve it once and for all. You get my point?
Yes, sir.
So there's no duration.
Okay, so most of the time when the technician says that the gas has finished in the AC is as a result of leakage, not
yes.
That. Okay.
Yes, from the beginning of the lecture, I use an example of water tank. You pump water in the morning, you are the only one staying in the building, you went to work. Only for you to come back, you discover the whole water is finished and nobody used water since. There's a leakage in the system. But what you keep doing now is that you keep pumping water every time. You have to identify where the leakage is coming from, then stop the leakage. Then the water will not leak unless you use it.
Wow. Thank you so much.
No problem. So then some of your technicians actually use it to eat money. They used to take money from you. Organic thing don't they leak, you give them money to go and buy refrigerant. Yes. There are sharp practice on site, sharp practice. Yeah, wow. Even sometimes capacitor will have problem. They will tell you, a compressor get problem. You can carve out about 50,000. Say me they go buy. He go enter market, go buy 5,000 naira. Go say I don't play this man. Hey, oh boy, Maga don't play. And surprisingly, he might win the best employee of the year.
Thank you so much, sir.
Yes, no problem.
Hello, sir.
Yes, please.
Sir, my question is, you were talking on downsizing and oversizing of AC.
Yes.
How do we calculate the size for a space for AC?
There's a rule of thumb, and there are software they use to calculate that. Rule of thumb is that you can use 1.8 kilowatts multiplied by the area. So I will give you an example. If the area of a place is 2 meters by 5 meters, that is what? 10 meters square, right? So you multiply it by the rule of thumb I've given to you, 1.8 times 10, we give you what? 18 kilowatts. And if you look at the length of the place is bigger, don't buy 1 unit. You can decide to divide that 18 kilowatts into 4 units. Effective distribution is required. When you design AC and you are blowing only the church member, you leave the pastor alone, it will affect the way he will preach for that day. You see him cleaning sweat most of the time. That's why you see most of the altar, you always have 2 AC, one blowing from the north, one blowing from the south, so that the man can deliver the speech he needs. It can also happen when you are giving a motivational speaker. You ensure that the AC within the front is cool enough for the guy to talk. So you understand? So rule of thumbs are not specific, because this rule, you might go to Meduguri and you fail. In Meduguri now, if from experience I might decide to use 2.5 kilowatts, multiply by that same 10, I will use 25. Instead of using 4, I decide to use 6 AC units because the environment is hot. But the rule of thumb, consider the number of people within the space, consider the activities they generate, because somebody sitting generates less energy compared to somebody dancing buga dance in clubs. You understand? So the rate they sweat is high. So you must consider all those things. The software they use is expensive. As at the last time, it is about $1,500 they buy it. The software to design. So most people just use rule of thumb to calculate. Rule of thumb can work if you have understanding of how to play with numbers. So you get, then try and divide your unit into instead of using 1, use 2 or 3, so that if one has problem, you can service the other one while the others are working. Don't use 1. It's a problem.
Okay, my second question is on ventilation.
Okay.
In my facility, we have a canteen running.
Okay.
And once that canteen starts operation, it's like the whole building
is on fire.
It's on fire, exactly. What I mean by fire is the smell of the food is all around the place in the building. So our concern was the building was initially designed not to have that canteen in that because
okay,
the
it was brought in
system,
later on.
Yes, it was something they factored in later. The ducting system was not reconsidered. Whatever activity that is going on in the canteen is being circulated everywhere in the building. So it became a problem. They did a lot, different consultation and all that. The problem was not solved until we now thought and said, the same duct that is running here is the same duct that is being circuit to the reception. So what we did was we had to break in the ducts, divide it, let the reception have its own circuit, while that of the canteen had its own circuit. And the return also was also rechanneled. That was what helped us to
solve, yes.
Resolve that.
The other solution you could also propose, if there was no other space, you could actually break and design a separate extraction. You know, there's what they call kitchen hood.
Yes,
you put
we
it exactly
also
on
had
top
that
of
kitchen hood.
Hood. Okay.
But the smell was too strong. You know, some people
no. Kitchen hood have various sizes. You know, when you want to sew a B, somebody that is very fat and somebody that is very slim, you don't buy the same size of clothes for them. So your kitchen hood, you must calculate the flow rate. It's possible the kitchen hood is brought, the fan extracting is not extracting as the required rate. If you know the volume of the things you want to be cooking there, you can actually design it according to the fan. The fan will remove it almost immediately as the thing is being cooked. But if you use a lesser fan, it will not remove it as required. It's a design issue. So since you have solved it, no problem. Any other question, please? One or two more questions before I go. Yes.
I wanted to confirm if the suction line and coils are the same thing.
No, they are different. When you say suction, something is sucking, and the liquid line is one is always cold and the other one is hot. The hot one is actually from the compressor going into the condenser. The liquid line is the one going straight to the evaporator, so it's always sweat. So it is advisable to insulate with what they call a mufflers. Then if you want it to be very well designed, you have what they call a wrapper, white wrapper you can use to wrap it to make it look neater. So there are two different things. Just like you have vein and artery, your compressor must have a liquid line and a suction line. Or some people say hot line, liquid line, yes.
Okay. And my next question is, what's the full meaning of CXV? CXV. What does it
CSV. Please, can you write it in the chat? Write it in the chat.
Okay, sir.
Any other question after this?
Please, sir, my last question.
Okay,
sir.
TSV. Thermostatic expand. TSV. Is that what you said?
Yes, sir.
That is thermostatic expansion valve.
Okay.
They also have another one they call electronic expansion valve. EEV, they call it sometimes. The X is expansion, then the other one is valve. It has a valve where you can lock and open. So when they say thermo, it responds to temperature change to either open it or close it, in addition to your sensor connected to your indoor unit. So each time you press your control, you're only telling your expansion valve to open or close. When you increase to 30 means you want the AC to produce hot. You are locking the expansion valve. It will not supply cool refrigerant going to the evaporator. Then when you want it very cold, you will press it to 18. That 18 is telling the expansion valve to open well. So thermostatic expansion valve is responding to temperature. Last question, please.
Okay, quickly, sir. My last question, sir. Regarding the types of AC, the VRF system, I quickly want to know if it's faulty. how is it possible to still experience cooling system in that particular apartment? Because it has different indoor, but the VRF is an outdoor. And if it's faulty, how is it possible to experience cooling system in the building?
If it is faulty, VRF system, like I said, it had different components. It works separately from each other. So when you put it on, it's possible that I'm not home. My own is not on, while the other person is on. So it can work separately. For a particular one, once it has fault, it is from the outdoor unit. You can actually detect which of the unit is faulty. There's what they call programming. In when you are commissioning the outdoor unit, there's a number that you must put in it. For the outdoor unit, if you have only one, you don't need to program. You only put all your outdoor units in code. If you have 10 outdoor units, the outdoor unit, indoor unit 1, you put it as 01 when you are programming it. Then the other ones 02 up to 10. So if one of them has fault, it brings out an error code on your display on your outdoor unit. So when you press the error code, it will tell you 01 with error code so. So you know outdoor unit in so flat is faulty. That is how you know, and you can actually isolate that particular one and find a solution to it. But I believe I've answered your question.
Yes,
hello.
Sir. Thank you. Yes, you've
Okay.
answered that.
Barakat, I think I am done with the class. So those who want to have my numbers, I will drop my number here. So those who want to write 080.
080.
Yes, 37.
37.
39.
39. Okay.
18. 15. Engineer Ejiro is my name.
Sir, please call the number again. The network is bad.
If you can check the chat, I drop it in the chat. Just check it before they log off. Have everybody opened their chat?
Yes, sir.
You see there 080 37 39 1815. Engineer Ejiro, please. So please, you can call me up if you are having little issues with your building. We can consult for you. Then if you need us to come do inspection, we can also come do inspection with our team. For those in Lagos, but for Abuja, you have to book flight. Oh. they say there are people picking people on the road, so I don't want to be picked. Okay, Barakat, I think I can go off now. Thank you very much. God bless all of you.
Thank you.
Thank you so much, sir.
Thank you.
God bless you. Bye.
Yes, sir. Bye. Great class.
So much. Thank you, sir.
Thank you, sir.